Hey, my name is Felipe and welcome to this image classification course. This is a fully comprehensive course and I'm going to teach you everything you need to know to get started with image classification, which is one of the most important techniques in computer vision. I'm going to cover the fundamentals and I'm also going to show you 3 different ways to train your own image classifier: the Python library Scikit Learn, the most recent version of YOLO V8, and a 100% no-code online platform called Teachable Machine. I'm going to show you the step-by-step process of how to use an image classifier in super complex projects. We will be building a computer vision API, a Pneumonia classification web application, and a face attendance system with liveness detection. By the end of this course, you will be more familiar with one of the most important techniques in computer vision, you will have the skill and knowledge to train your own image classifier, and you will be able to build super amazing computer vision projects. And now, let's get started! So let's get started with this course about image classification, and the first thing we will be discussing is what is image classification. I'm going to share with you a very simple definition and a few examples. Image classification is a computer vision technique to categorize an image into one of several predefined categories. And this is very important, we will be categorizing an image into one of several predefined categories. There are many technologies to perform image classification. These are only a few of all the available technologies, of all the different ways in which we could do image classification. For example, we could use the Python library Scikit Learn, which is a very popular library for machine learning. We could also use YOLO V8, which is the most recent version of YOLO. We could use Teachable Machine, which is a very powerful framework provided by Google to do image classification with absolutely no code whatsoever. It's a 100% no-code platform. We could also use image classification through a cloud provider, for example using AWS Recognition, and these are only a few of all the different ways in which we could do image classification. And this is the high-level structure of an image classifier. Absolutely every single image classifier needs to comply with this structure. The input will be an image and the output will be the image category, and the category will be given either as an integer value, for example 0, 1, 2 and so on, or as a string, for example cat or dog, or as a vector. But let me give you a very specific example. So here we have a very simple image classifier, and in this case we will be classifying absolutely every single image into one of these 2 predefined categories. This image classifier is going to take an image and is going to classify this image, is going to categorize this image either as a cat or as a dog. And in this case, this image classifier takes this image of a cat and it returns the category cat, right? This is a very specific example, and now let's continue. Now let's talk about image classification confidence score. Image classifiers usually provide a measure of confidence along with their classifications. They usually provide a measure of confidence. Not always. This is something they usually do, right? Remember, an image classifier will always return the image category, but they usually also return the confidence score. Usually, not always. This confidence score is a float value in 0, 1, so it ranges from 0 to 1, and it represents how confident the image classifier is regarding that classification. So in the previous example, in this case we are classifying this image as a cat with a 0.95 confidence score. We can look at this number either as a float value, and this will be 0.95, or we can look at it as a percentage, and in this case it will be 95%. So this means this image classifier is telling us this image is a cat with a 95% confidence. So this means this image classifier is not 100% confident this image is a cat, right? This image could be a cat or it could be a dog. The image classifier could be making a mistake. It's not 100% confident, but it's a 95% confident, right? That's exactly what it means, the confidence score. We are making a classification and we are providing a value of how confident we are regarding that classification, right? Now let's continue. These are some very specific examples, some very specific applications of image image classifiers. And these are some examples we covered in my previous tutorials in this YouTube channel, and these are some examples we will be covering through this course. So the first one is a parking spot classifier, and this is a classifier which takes an image of a parking spot and it classifies this image into one of these two categories. So this classifier is going to take an image of a parking spot and is going to classify this image as empty if the parking spot is empty, or it's going to classify this image as non-empty if the parking spot is occupied either with a car or any other type of object. This is a very interesting application we will be covering later on this course. Then another example is a weather classifier, which is going to take an image and is going to classify an image into one of these four predefined categories, which are rain, sunrise, cloudy, or shine. And this is another example we will be covering later on. Then another example is a ship classifier, which is going to take an aerial image, a satellite image, and is going to classify this image as ship if the image contains a ship, or as no ship if the image does not contain a ship. And then the last example, and this is a very advanced application of an image classifier, which is a spoofing classifier. And the idea with this type of classifier is to detect these type of situations of someone holding someone else's picture, right? In this type of application, we will be classifying human faces into one of these two categories. We will be classifying every single face either as fake, if the person is doing something like this, if it's holding someone else's picture, or as real, if it's someone holding its real face, right? If it's a real face in front of the camera. So these are a few examples of some image classifiers which we will be covering through this course. And now let's continue to the next lesson. Now let's talk about image classification metrics. Let's try to answer the question how to measure the performance of an image classifier. We will be discussing three different types of metrics: a confusion matrix, accuracy, and precision and recall. Precision and recall are two different types of metrics, but we will be addressing both of them at once. So let's start with the confusion matrix. It summarizes the performance across all of our classes. It's a very visual way to evaluate a classifier. The ideal confusion matrix is a diagonal. Now let me show you, this is how a confusion matrix looks like in the case of only two classes. We will have four numbers which will be arranged as a matrix. And the way we will make sense of these four numbers is exactly like this. The number we will have over here, the true positives, is how many samples of this class, the class number 1, were classified as the class number 1. Then this other number, the false negatives, means how many samples of the class number 1 were classified as the class number 2. Then the false positives means how many samples of this class, the class number 2, were classified as the class number 1. And the true negatives means how many elements of the class number 2 were classified as the class number 2. This is going to be much more clear later on because I'm going to show you a couple of examples of how to compute a confusion matrix. Now let's continue. Let's move on to the accuracy. The interpretability of this metric is very straightforward if classes are perfectly balanced, and the higher is better. And this is exactly how we are going to compute the accuracy. Basically, we will need to take the elements in the diagonal, the true positives and the true negatives, and we will need to divide these numbers by the total number of samples, right? TP means true positives and TN means true negatives. So, true positives plus true negatives divided the total number of samples. Now let's move on to the precision and recall, and these are the most appropriate metrics if classes are not perfectly balanced or if misclassifications are too expensive. And I'm going to show you an example in a few minutes of an image classifier where the misclassifications are too expensive. So this is going to be much more clear in a few minutes. But for now, let's continue. Recall measures how effectively we can find objects. Precision measures how well we perform once we find an object. And the higher is better for each one of these metrics. Now let's continue. We need to define a positive class and a negative class. Precision and recall are computed with respect to the positive class. So, going back to the confusion matrix, you can see we have two classes. We need to define one of our classes as the positive class and the other class as the negative class, right? And the way we have built this confusion matrix, we have over here the class number 1 will be the positive class and the class number 2 will be the negative class. Going back here, once we have defined these two classes, the positive and the negative, we can compute the precision as the number of true positives divided by the number of true positives plus the number of false positives. Going back here, we will need to take this number, the true positives, and we will need to divide this number by the sum of the true positives plus the false positives, right? We will take this number and we will divide it by the sum of these two. Going back here, then we will need to compute recall as the number of true positives divided by the number of true positives plus the number of false negatives. Going back to the confusion matrix, it will be like taking this number, the true positives, and dividing this number by the sum of these two, true positives and false negatives. So we take this number and we divide it by these two, by the sum of these two. Now let's continue. Let's take a look at a very specific example. Let's assume we are working with a cat-dog image classifier. So we have an image classifier that classifies every single image either as cat or dog. And now we are going to test this classifier and we have 500 images of dogs and 500 images of cats. And let's assume that 420 images of dogs were classified correctly and 400 images of cats were classified correctly. If we build the confusion matrix in this problem, we will have something like this, right? 420 dogs were classified correctly, and this is exactly what we have over here, and 400 cats were classified correctly. And this means that 100 cats were misclassified as dogs and 80 dogs were misclassified as cats. In this case, the accuracy will involve to sum the elements in the diagonal, in this case is 420 plus 400, divided by the total number of samples, which is 1000, and this is 0.82. Then precision, we will need to take this number 420 and then divide this number by the sum of 420 plus 100, and this is something like 0.81, right? Then recall, we will need to take this number 420 and we will need to divide this number by the sum of 420 plus 80. This is exactly what we have over here, and this is 0.84. So in the case of this very specific example, we have these values for the accuracy, the precision, and recall. Now let's move to a slightly more advanced problem, to a slightly more complex image classifier, which is something like this. This is a spoofing classifier which is going to classify every single image into either fake or real, and these are images of human faces, right? So fake means if the user is doing something like this, and real means if it's a user with its face looking at the camera and without doing anything like this, right? A real face. And we are going to test this classifier, and we have 500 images of real faces and 500 fakes. And we get these values: 280 fakes were classified correctly and 480 real faces were classified correctly. If we plot the confusion matrix, we will have something like this: 280 fakes were classified as fakes and 480 real images were classified as real. Let's continue. The accuracy, we will need to sum all the elements in the diagonal: 280 plus 480 divided by 1000, and this is 0.76. Then for the precision, we will need to take this number and we will need to divide this number by the sum of these two, which is 280 divided 280 plus 20, and it's 0.93. Then for the recall, we will need to take this number and we will need to divide this number by the sum of these two, and this will be 0.56. So for this image classifier, we will have these values for these three metrics for the accuracy, precision, and recall. And the reason I consider this is a slightly more complex and a slightly more advanced problem is because if we consider this case, if we consider this image classifier, if we assume this is working in something like a face attendance system, let's consider these two situations. Let's consider we have a real face which is misclassified as fake. So someone is trying to log in into a system, and this system, this face attendance system, tells the person it's fake. So that's the first situation we will need to consider. But if you think about this situation, it's not really a big deal, right? Because if a person is classified as fake, the only thing this person will need to do is to try to log in once and again until it's classified as real, and that's it. And eventually the only thing this person will need to do is to call its supervisor or to call its support or something like that to fix this situation, to fix the issue. It's not really a big deal. But let's consider the other situation. Let's consider someone who is holding someone else's picture, someone who is pretending to be someone else, and this someone is classified as real, right? This someone is not classified as fake as it should be, but is classified as real. This is a huge issue, because in this case it means someone has gained unauthorized access into the system, and that's huge. That's a huge issue. So this is an example in which we have a misclassification which is too expensive, right? And in this type of situation, the accuracy is not really that important. The precision is not really that important, but the recall is the most important metric of all, because we want to detect this situation as often as possible. Ideally, we would like to detect absolutely all of these situations, and you can see in this case the recall is 0.56, which means this is a 56%, which means 44% of all the people who are trying to impersonate someone else are getting away with it. That's what it means, 44%, which is a lot. That's a lot of people, which means we have a huge problem. So this is only to give you an example of a slightly more complex case of an image classifier, of the evaluation of an image classifier, and this is going to be all for this lesson. Now let's continue to the next lessons, where I'm going to show you how to build your own image classifier. Hey, my name is Felipe and welcome to my channel. In this video we are going to make an image classifier. Image classification involves classifying an image into different categories, and it's one of the most important fields in computer vision. I'm going to show you how to make an image classifier, which is very simple, very robust, and it works 100% in Python. I'm going to walk you step by step through the entire process, how to prepare the data, how to train the classifier, and how to test its performance. So, following the steps of this tutorial, you will be able to build a very robust image classifier in only a few minutes. So let's get started. So this is the process in which we are going to be working today in today's tutorial. You can see that this is a 4 steps process, so training this image classifier will take only 4 steps. This will be a very easy and a very straightforward process. Now, let me show you the requirements we are going to use in this project. We are going to use Scikit Learn, Scikit Image, and NumPy. And the image classifier we're going to use comes from the library Scikit Learn. This is a library which is very popular to solve machine learning related problems, and if you want to work with computer vision or with machine learning, you will definitely need to be familiar with Scikit Learn. So this will be a very good example, this will be a very good opportunity in order to get more familiar with Scikit Learn. Now, let's start with this project, let's start with this tutorial, and the first step is preparing the data we are going to use in order to train this image classifier. And now let me show you the data we are going to use in today's tutorial. This is the data we are going to use. You can see we have 2 different categories. The categories are empty or not empty. This sounds very strange, but let me show you exactly how these 2 categories look like, or how the data in each one of these categories look like. And you can see from the not empty category, we have something that looks like this. So basically we have cars. These are images from cars. And if I show you many different pictures, you can see that in all of them we can see pretty much the same situation. It's like a car. That's basically the not empty category. And then if I show you the empty category, this is pretty much an empty something. This is pretty much all images containing emptiness, containing a completely empty these are completely empty images. In some of them they are very small objects, but you can see that all of the images are mostly empty. And these are how these two categories look like. This is how these two categories look like. And this data comes from one of my previous videos where I show you how to create a parking slot detector and counter using Python and computer vision. In this other video, I show you how to take a video exactly like this, from a video from a huge parking lot like this, and to make it look like this. Let me execute the code I show you how to build in this tutorial. And the idea was to go from here to here. The idea was to build something like this where we detect absolutely all the parking slots, and for each one of the parking slots we classify if the parking slot is empty or not. And if it's empty, we plot it in green, and if it's not empty, we plot it in red. So this is exactly where the data comes from, the data we are going to use in today's tutorial. You can see that for the not empty category, this is how the data looks like. These are images from parking slots containing cars, and from the empty category we have images from parking slots which are completely and absolutely empty. So this is the data we are going to use today. And the image classifier I'm going to show you how to build in today's tutorial, it's a very robust classifier in situations like this, in situations where the data we have, in situations where the classification we want to make on our data, it's very easy, it's very simple, right? Where the different categories we want to tell apart, the different categories we want to classify, they are visually super distinct. They are super different, right? In this case, we have images from cars, and in the other category, we have absolutely empty images, right? The image classifier I'm going to show you today, it's very robust and it works super well in situations like this. And the reason I'm saying this is because this may not be a state-of-the-art image classifier. If you look for papers or if you look for the most recent techniques, obviously you are not going to find the classifier we're going to make today, we're going to build today. And it's definitely not the most robust classifier in the machine learning industry. But if you want to solve like a very simple problem like the one we are going to solve today, this image classifier will be more than enough. And I'm going to show you exactly what's the performance we achieve with this classifier, but that's later on in this tutorial. Now let's get started. I already showed you the data we are going to use, and the first thing I'm going to do is to import OS, which is a library which we definitely need in order to work with data and to read data and to load data from our computer. So I'm going to define a directory which is input directory, and in this case I'm just going to hard code where the input directory is located, which is here. This will be something like this, and then I'm going to define our categories, and I'm also going to hard code it, and I'm going to say something like this: our categories are empty and not empty. Okay, and then the only thing I'm going to do is to define two lists, which are the lists which are going to contain our data. One of them will be data, and then the other one will be labels. And I'm going to show you exactly how we're going to use these two objects later on this tutorial. And now what we're going to do is to iterate in absolutely all the images in these two directories, and we are going to load these images, we are going to read these images, and we are going to format the images, this data, in a way that fits well the classifier we're going to use later today. So let's start with it. I'm going to say something like for category in categories, and then for file in something like os list dir input dir, and then I'm going to define the image path like os path join, and then input directory and category, and sorry, this will be os.path.join input dir and category. Okay, because we are working in absolutely all the files for each one of our categories, right? Something like this. Okay, image path join input dir category, and then file, And then we have defined exactly what's the location of our images. Now the only thing we need to do is to read our images and to save our images into this list. So in order to read our images, I am going to import from skimage.io import imread. In this channel, in all the videos I have made so far, we usually used OpenCV as an image processing library, and obviously OpenCV it's by far the most popular and the most comprehensive of all image processing libraries. It's the one I use the most in my projects. But there are also other libraries which are more convenient in different situations, and for example in this case we are going to use Scikit Image. We're going to use this image processing library in order to read the images from our disk, from our computer. So I am going to call imread from image path, and this will be image. Okay. And now I'm going to resize this image, and for that I am going to import another function from Scikit Image, which is called from scikit-image.transform import resize. So I'm going to call resize. I need to input my image and I need to input the new size, which the new size I'm going to resize all my images to, which is 15 times 15. And this will be my image. So I'm walking through absolutely all the images in these two directories. I'm taking these images, I'm reading these images from my computer, and I'm resizing these images from this size to 15 times 15. Okay? Now let's continue. I have resized all of our images, and what I need to do now is to append this data into the list I have created in order to contain all my data. So data.append, and we're not going to append the image like the image we have read and we have resized, but we are going to append the flooded image. We are going to take our image and we are going to make it into an array, right? Because currently our image is something like a matrix, right? It's something like a matrix of size, for example, in this case, 61 times 26 and 3 channels. It's BGR. We have resized this image. Now it's 15 times 15 and 3 channels. Now we want to take all of that information and we want to make it into only one very, very long array, right? We want to make it unidimensional. So that's why we are calling flooded. And the reason we are doing this is because that's what we need to do in order to use the image classifier we're going to use today. When we are working with machine learning, you will notice different classifiers and different models and different libraries and different so on, different everything require different formats, or require we format the data differently in order to be fed into the machine learning model, into the classifier or into the whatever we are using. And in this particular case, we need to flood the data. We need to make the data into an array before we input this data into our classifier. So that's all for the data, and we also need to append the category for this data, the label. And in order to do that, I'm going to walk through the categories in a slightly different way. I'm going to call this is category index category in enumerate categories, and now I will append category index to this labels array, to this label list. And that's pretty much all we need to do. The only thing I'm going to do next is to cast each one of these lists into an NumPy array. So I'm going to say as array and then date. Okay, and I'm going to do the same with labels. NP as array labels. I know what you're thinking, hey Felipe, this is not going to work because you have not imported NumPy. And you are completely right. So I am going to import NumPy now. Import NumPy as NP. Okay, so that is it. That's all we need to do in order to load our data and in order to prepare our data to be fed into the classifier, or in order to move to the next step. That is it. We have completed the first step in our process. So congratulations. We are one step closer to reach our goal of training our image classifier. Now, in order to make sure everything works properly and we don't have any error, I'm going to execute the code as it is now. And numpy has no flooded. Maybe it's flattened. I think it's flattened. Maybe I made a mistake. So let's see what happens now. It seems we don't have any error. So yeah, I made a mistake. Now we have to wait a few minutes because remember, we are working through absolutely all the images in these two directories. And we have, among the two directories, we have 6,090 images. So this is going to take some time, but yeah, now it's completed. And now it's time to move to the next step, where we are going to split our data into two different sets. We are going to create a training set, and we are also going to create a test set. The training set is the one we are going to use in order to train our image classifier, and then the test set is the one we are going to use to test the performance of the classifier we are going to train. So we definitely need to split all of our data into these two sets, and this is the function we are going to use. We need to import another function from Scikit Learn, and this function will be something like from Scikit Learn dot model selection, if I'm not mistaken, import train test split. Yeah. So this is how we are going to use this function. I'm just going to write some things and then I'm going to explain it. So this will be something like xtrain, xtest, ytrain, ytest. This calling our data x and y, it's a very popular convention in machine learning, so we are going to do it too. And this will be our train test split function. And we need to input data, labels, and then there will be other parameters as test size. I'm going to set this in 20 in 0.2. Don't worry, I'm going to explain exactly why I'm setting all these parameters in a couple of minutes. Then another parameter is stratify. This will be according to labels, and then shuffle. I'm going to call shuffle here, and this will be true. Okay, so I have called train test split. I have input our data and our labels, and then I have specified a few parameters. In order to show you exactly what these parameters mean, I'm going to start with test size. I told you we were splitting our data into two different sets, the training set and the test set. Now let me show you an image to show you more what this means, to show you exactly how this looks like. So this is an image I found online. This is an image I found on Google, or actually on DuckDuckGo. And basically you can see that we have an array which is called data, which contains all of our data, and we're creating two different arrays from it. We are creating xtrain and xtest, and we are specifying this size, this split size, which is 0.2. So what we are doing is creating two different sets, which are training set and test set, from the total amount of our samples. From all of our data, we are splitting all of our data into two different sets, and the way we decide what's the size of the test set is by specifying this parameter. So currently we are telling train test split to make this split in a way that 20% of all of our samples are in the test set, right? Now, moving to the next argument, shuffle equal true. This is something that we always want to do when we are creating data, when we are preparing data in order to be fed into a machine learning classifier. We definitely want to shuffle this data first, so we can avoid absolutely every bias we had when we were reading the data, when we were creating these data arrays. We definitely want to shuffle the data first. This is a very good practice. Sometimes there are some biases which we are not aware of. Sometimes the way we are reading the data or the way we are creating these arrays, we are making some mistakes, or we are, I don't know, the way this walking is done, maybe it's alphabetical order, or maybe it's whatever. We always want to shuffle the data first. That's a very good practice to avoid any type of bias when we were reading the data and creating these arrays. Then stratify equals labels. I will say it's always a good practice when we are splitting our data into two different sets to define exactly how we are stratifying this split. And in order to show you exactly what stratify means, I'm going to show you this picture, which I also found online on DuckDuckGo. And basically you can see that we have a data set. In this case is these 12 people, and you can see 3 of these people are blue, 3 of these people are green, and then 6 of these people are red. And in this example we are taking a sample of 4 elements of 4 people, and the way this sampling is done is by stratifying by the different labels. So if you look at the sample, you can see that 2 of these samples are red, 1 of the samples is green, and the other one is blue. So we are keeping the same proportion of the different labels in our original dataset. That's exactly what we are doing when we are stratifying according to the labels. It's like a way to make sure that all the different labels are going to be in exactly the same proportion as in the original dataset. So it's definitely a good practice. This is something we always want to do. Now let's continue, and you can see that we have completed the second step in our process. We are one step closer. We have only 2 steps left, 2 steps to go. We are one step closer of training our image classifier, and that's going to be all for splitting our data into a training set and a test set. Now it's time to train our image classifier. Now it's time to do like the actual training. And this is how we are going to do it. I'm going to import another function, which is called, if I remember correctly, from Scikit Learn. I think it's model selection as well. Import grid search CV, and then from scikit-learn.svm import svc. Okay, so the first thing I'm going to do is to define an object which is called classifier, and this will be something like this. This is the classifier we are going to use. It's svc. Let's see if it's okay. Scikit-learn svm export. I think it's okay. For some reason it doesn't really found it. Oh, I see what's the error. SVC should be in capital letters, and now everything should be okay. Okay. So what I'm doing here is creating a new instance of this object, and I'm calling this object classifier. And this is the classifier we are going to use in order to train our image classifier. So what I'm going to do next is to define another object, which is parameters. And this will be something like this. I'm just going to write it, and I'm going to explain it in a couple of minutes. I'm going to define something like a list of only one element, which is going to be a dictionary with 2 keys. One of these keys will be gamma, and then the other key will be C, and that's pretty much all. And then I'm going to define a list for each one of these items. And for gamma, it will be something like 0.01, 0.001, and 0.0001. Okay. And for C, I'm going to do something like 110, 100, and 1000. Okay. And then it's when I'm going to call grid search. I'm going to define a new object, which is called grid search. And this will be grid search CV. And I'm going to input these 2 objects I just created, the classifier and the parameters. Okay, and now let me show you exactly what I'm doing. I'm creating a new instance of SVC, and I'm calling this instance classifier, and this is the classifier we are going to use. And I'm creating this object which is called parameters, which is a list containing only a dictionary, and this dictionary has only 2 keys. One of them is gamma and the other one is C, and each one of these keys has a list of values. Okay, now I'm going to show you the Scikit Learn documentation. I'm going back to Scikit Learn, and I'm going to show you how the documentation looks like for SVC, for the object we are using as our classifier. And you may notice all the different parameters we have in this classifier. We have C, kernel, degree, gamma, coef0, shrinking, probability, and many other parameters. We have many different parameters to choose from, but when we were creating our object, we are just calling this empty constructor. We are not specifying absolutely any parameter. We are just using all the default values for SVC. Okay. And you may notice as well that we are creating this other object, and these two keys we are creating are exactly two parameters from our SVC, from our object, from the object we are going to use as our classifier. So what we are going to do is we are not going to train only one image classifier. We are going to train many different image classifiers, and we are going to train an image classifier for each combination we have for C and gamma. So we have 3 values for gamma and we have 4 values for C. This means we are going to train 12 image classifiers, right? The way this process is going to work is that we are not going to train only one image classifier, but we are going to train many, and as many as different combinations we have for C and gamma. In this case, we have 3 values for gamma, 4 values for C, 3 times 4 is 12, so we are going to train 12 image classifiers. That's the process we are going to take in this tutorial, and the way it works is that we are going to choose the best of all of these different classifiers we are going to train. So, and the way we are going to do this training, the way we are going to train as many classifiers as at once is by calling grid search, by calling this other object I have specified over here. So this is how we are going to use it. I have already defined this grid search, and then the only thing we need to do is to call grid search dot fit, and I'm going to input xtrain, which is my training set, and then whitetrain, which are the labels of our training set. And that's pretty much all. That's pretty much all in order to train our image classifier. That's pretty much all to train all these 12 image classifiers, right? Let's see what happens when I press play. Now, remember, the way this works is that we are loading the data first, and this is going to take a few minutes because it's a lot of data. These are a lot of images, and then we are taking this process. Now, the training also takes some time because remember, we are training many different classifiers, so this is going to take some time. So I'm just going to wait a couple of minutes, and I'm going to see if something happens or if the execution is successful. Okay, so the execution is now completed, we don't have any errors, so we can continue. And this was the third step in our 4 steps process. This means we are pretty much there. The only thing we need to do now is to test the performance of the model we trained. But we are almost there. We have almost completed this process, and most importantly, we have already trained our image classifier. Our image classifier is now trained. The only thing we need to do now is to test how it performs to see if we can use it or not. Okay, and this is how we are going to do. I mentioned that we were training not only one image classifier, but we are training 12 different image classifiers, one for each combination of C and gamma. So we are training many different classifiers. And the way we are going to select one of all of these image classifiers is by calling a member of grid search, which is called gridsearch.bestestimator_. So by calling this member is that we are going to get the best of all the different image classifiers that were trained, right? We are training 12 different image classifiers, and we are just choosing the best one. And the way we are choosing for the best one is by calling this member of grid search. That's basically what we are doing. So this is our model, this is our classifier, best estimator, this is our model. Now let's see how it performs. Let's see if it's really like a good classifier. Let's see what's the performance of this classifier on our test data, on the data we have created in order to test the performance of this algorithm. So what I'm going to do is to call bestestimator.predict, and I'm going to input my test data. So I'm going to input xtest, and I'm going to call the output from this prediction yPrediction, right? And then I need to import another function, which is from Scikit Learn metrics import accuracy score. And let's see what's our performance. And I'm going to make a print. I'm going to define another value, which is score. And score will be accuracy score, Y prediction, and Y test, right? I'm taking these, which are the labels of the test set, and I'm just comparing against our predictions. And now I'm going to print something like, I'm going to format this super nicely so we get like a very clear measure of how well this performs. So I'm going to express this as a percentage, and I will say something like of samples were correctly classified, something like this. And this will be format string score times 100, right? Because score is going to give us a number which ranges between 0 and 1, and it's going to be a measure of our score, of how accurate our classifier is on the test set. Now, this is a value between 0 and 1, and it's very useful, and that contains absolutely all the information. But what I'm going to do is just reshaping, we're going to do like a reformat of this number into a percentage, right? Because it's going to be much cleaner in order to see how it performs. And all I have to do now is to execute this code again, and let's see what happens. Let's see what's our performance. So I'm just going to press play, and I am going to wait a couple of minutes just like before, and I will come back with our results. Let's see how it performs. The execution is now completed, and this is the accuracy we got with the best estimator from all the different image classifiers we trained. We are getting a 99.9% accuracy. This means that this is absolutely perfect. This is a pretty much perfect classifier. A 99.9% accuracy is like a super high performance. It's like a very good performance. So we can definitely use this classifier later on. We can definitely use this classifier in order to use it in our project. So the only thing we need to do next, the only thing we have to do now in order to complete this tutorial is to save this classifier, to save this model, because we want to load this model from another project, or we want to load this model in a different code or in a different whatever, from a different location. We definitely want to save the weights, or we want to save exactly all the information which is related to this model so we can use it later in a different project. And the way we are going to save this model is by using Pickle, which is another Python library. So I'm going to import Pickle, and then I'm just going to call pickle.dump, and I'm going to specify the model I want to save, the object I want to save, and also I need to specify the file, which is going to be something like model.p, and then I need to open this file as wb. Okay, and that's going to be pretty much all in order to save our model, and in order to have a file with our model so we can use it later on our project or from our location, or we can use this file in whatever way we want. So I'm going to press play, and that's going to be pretty much all. After the training process is completed and after everything is done, we should have a file in exactly the location we have specified, which in my case is here. We should have a file which is called model.p. So this is it. This is going to be all for this tutorial. We have absolutely completed all the steps in our process. We have completed all 4 steps in our process, and we have trained an image classifier using Python and Scikit Learn. Hey, my name is Felipe and welcome to my channel. In this video I'm going to show you how to make an image classifier using YOLO V8 on your own custom data. I'm going to show you every single step of this process, from how to organize the data so it complies with YOLO V8, how to do the training in your local computer, and also from a Google Colab, how to validate the performance of the model you train, and finally how to take the image classifier in order to make new predictions. I'm going to show you the entire process. This is going to be an amazing tutorial, and now let's get started. So on today's tutorial, I'm going to show you how to train an image classifier using YOLO V8 on your own custom dataset. So let's get started. And the first thing I'm going to do is to show you the data I am going to use in this tutorial, which is a weather-related dataset. Let me show you the different categories we have, and let me show you all the different images, how they look like. We have 4 different categories, and they are cloudy, rain, shine, and sunrise. Now let me show you each one of these categories. For example, the cloudy category, this is how the images look like. You can see that in each one of these images we have a sky which is completely cloudy, right? We have many different clouds for each one of these images. Now the sunrise category, it's basically many different pictures of sunrises. So this is how this category look like. And now for the shine category, we have a sky which is completely clear and with a super bright sun, right? You have the sun in each one of these images and it's super bright. And this is a rainy category, and you can see these are many different pictures of super rainy days. So this is basically the dataset I am going to use in this tutorial, but obviously you can apply absolutely everything I'm going to show you today to absolutely any type of dataset. You are going to be able to build any type of image classifier with everything I'm going to say in this tutorial. Now let me show you the structure you need for your data, because if you're going to train an image classifier or if you're going to use YOLO V8, yes, the data is super important, but you also need to structure, to give like a format to all of your data so it complies with the way YOLO V8 expects your data to be, right? Or YOLO V8 requires your data to be in a given format, in a given structure. So I'm going to show you exactly how to structure your file system so everything looks the way it should to train an image classifier using YOLO V8. So if I show you, I have a directory which is called weather dataset. This is going to be the root directory. You can call this directory whatever you want, but you need a directory which is going to be your root directory. And inside this directory, you can see we have 2 different folders. One of them is called train and the other one is called val. And this is exactly where you're going to have your training dataset and your validation dataset, right? It's very important you name these directories exactly like this. One of them should be called train and the other one val. Now, if I show you within the train directory, this is where we are going to have our 4 directories containing all the different images for all of our categories. Basically, you need to have as many directories as categories you want to classify with your model. So in my case, I want to classify an image into 4 different categories, and this is why I have 4 different directories, 4 different models. Each one of these directories is named as the category I want to classify my images in, right? One of them is called cloudy, the other one is called rain, then shine, and then sunrise, and these are the categories I want to classify all my images. And then within these directories, these folders, is where I have all my data. Within cloudy is where I have all my data related to the cloudy category and so on, right? The same happens for the rain and the shine and the sunrise category. So this is basically the structure you need for your data, the structure you need for your file system in order to comply with what YOLO V8 is expecting for your data. And then if I go to the val folder, you can see I have exactly the same structure. I have 4 different directories and they are named under the categories I want to classify all my images. And then if I open these directories, it's exactly the same. You can see that I only have different images for that specific category. Now this is very important because from now on everything is going to be super straightforward. If you have created this structure for your file system, if your data is exactly in the structure I show you, then it's going to be super simple to train an image classifier using YOLO V8. So this is very important. Now I'm going to show you 3 different ways in which you can train an image classifier using YOLO V8. So let's start with the first way, which is using a Python script. We are going to make a very simple script in Python in order to train this model, and let me show you how to do it. So let's go to PyCharm. This is a PyCharm project I created for today's tutorial, and the first thing you should do if you want to work with YOLO V8 is to install a couple of dependencies, a couple of Python packages. These are 2 packages we are going to use in this tutorial. One of them is Ultralytics and the other one is NumPy. Ultralytics is very super important because this is exactly the library you need in order to import YOLO, in order to train this model using YOLO V8. So you definitely need these 2 packages. Now, in order to install these packages, this is how we're going to do it. I'm going to show you a way to install these packages, which is going to work with whatever your OS, right? If you are a Linux user, or if you are a Windows user, or if you use Mac, it doesn't matter, it's going to work anyway. So you need to go to File, then Settings, and then you have to select Python interpreter, right? This is the Python interpreter you're going to use. You can see that I'm using Python 3.8, and then you need to click on plus, and this is where you're going to search for the packages you want to install. In my case, I'm going to search for Ultralytics, and the version I'm going to use, let me copy the version first. It's this one, so I'm just going to File, Setting, then Ultralytics again, and then the version is this one. Okay, and then I click on Install Package. In my case, I have already installed this dependency, so nothing is going to happen on my computer, but please remember to do it on your computer, because otherwise you will not be able to use, or you're not going to be able to do anything of what we are going to be doing today. Now let's see NumPy, what's exactly the version we are going to use. We're going to use 1.24.2. So File, Settings, plus NumPy 1.24.2. So everything is okay. Now install package. This is like everything is okay. NumPy has been installed successfully. So now we are ready to continue. Once you have installed these two dependencies, these two packages, now you're ready to continue, and now you're ready to install your own image classifier using YOLO V8. So let's go to main. This is the file we are going to use in order to code everything we need in order to train this classifier. And let me show you exactly what's the code you need to type in order to do this training. I'm going to over here to the GitHub repository of YOLO V8, and I'm going to select the classification section, right? I'm going for the classification, and then here I'm going to click on classification docs. This is going to open a new file, a new URL, a new website, a new page, and this is exactly all the information we need in order to train this image classifier. I'm just going to scroll down, and I'm going to the train section, and this is what we're going to do. I'm going to copy and paste this line, which is the one in the middle, the one that says load a pre-trained model recommended for training. I'm just going to copy, and then I'm going back to PyCharm, and I'm just going to paste it. Obviously, we need to import YOLO, otherwise this is not going to work. So I'm going to say from Ultralytics import YOLO. And that's pretty much all. You can see now we are creating our model, or we are creating the object we are going to use as our model. And then I'm just going to copy and paste this last line, which is model.train. I'm going to paste it here, and then I'm going to make a few edits. I'm going to leave like this value. I'm going to leave the image size in 64, but then for the number of epochs, I'm going to set it in 1. Right? Because the first thing we're going to do is we're going to do a very dummy training in order to make sure everything works as expected, in order to make sure everything works properly. And once we are completely and 100% sure everything is okay, we are going to move forward with a more deeper training and with a more real training, right? But for now, let's just do the training for 1 epoch, and let's see how it goes. Then for data, this is where you're going to specify the absolute path to the data you are going to train this model with, right? In my case, it's going to be this weather dataset. So I'm just going to copy and paste the absolute path of this dataset, which is this. I'm going to copy this path, and I'm going to paste it here, right? This is the data I am going to use. Remember that you need to specify the absolute path to the root directory of your data. And remember, you need to structure your data into the exact format I already mentioned, right? Otherwise, this is not going to work. And that's everything we need in order to train this image classifier. So the only thing I'm going to do is to press play. I'm going to run this script. So let's see what happens. Remember, we are running this training, we are doing this process for only 1 epoch, because we need to make sure everything works properly. And once everything is working properly, we are just going to edit this value, and we're going to make this training for more epochs. But you can see everything seems to be working properly, so everything seems to be okay, and everything seems to be completed, and everything seems to be ready. So that's it. And you can see that the results have been saved here in runs, classified, train 12. So let me show you exactly where this directory, where this location is in my file system. If I go to the project, the PyCharm project I created into my file system. This is exactly the project I created. This is the file we are currently working in, the main.py file, and this is where my data is located. And this is where the runs directory, the runs folder will be located. This is where it will be created. You can see that within runs we have another directory which is called classify, and here is where you will have many folders for each one of your training processes. And you can see that in my case I have trained this classifier many different times while I was preparing this video, so there are many directories for me, but this is exactly the one which was just created, the train 12, right? Train 12. This is exactly the directory which was just created, and if I open this directory, you can see we have another directory, and then we have two files. I'm going to explain what exactly all these different files and all these different folders are, and exactly what's the information we have in all these files, but I'm going to do it later on this tutorial when we are validating this training process, right? For now, just remember all the results will be saved here, will be saved within this folder, within the runs folder, and then within classify, and then a new directory, a new folder will be created for the training process you have just executed, right? This is something you need to remember for now, but later on in this tutorial I'm going to show you exactly how you can validate the training using the information that's within this directory. But for now, let's continue. I'm going to show you now a different way in which you can train this image classifier using YOLO V8. I'm going to show you how to do it using the command line, using this utility, and this is actually like a very straightforward way to do this training. Let me show you. You can see that we have 3 different examples. I'm just going to select this one. I'm going to copy and paste this instruction, this line, and I'm going to show you how I do it. I'm just going to paste it here, and you can see that we have many different parameters, right? In the first word is YOLO, this is the utility we are going to execute. Then classify, this is the task we are going to execute. We are going to train an image classifier, and then we are going to train it. So we have another keyword which is train, and then we have these arguments: data, model, and epochs, and also image size. I'm going to do exactly the same with image size. I'm just going to leave this value in 64, but then I'm going to edit all the other values. Or actually, I'm going to edit number of epochs, and I'm also going to edit data. For the number of epochs, let's do something similar. I'm just going to do it for one epoch, so we make sure everything runs smoothly and everything runs properly, and then we can do like a more serious training, a more real training for more epochs. This is exactly the model I'm going to use, so I'm not going to edit this keyword either, and then I'm going to edit this argument, and I'm just going to say this is the absolute path to my data. So this is going to be exactly the same as I have over here. Something like this. Okay, and that's pretty much all. The only thing I need to do now, I'm going to copy and paste this sentence, and I'm just going to the terminal, and I'm going to do something like this, right? I'm just copying. I have just copy and paste that sentence, and you can see that that's all we need to do in order to train this image classifier using YOLO V8. You can see that the model, the training process has started, and everything is running super smoothly. So everything is going super well. That's all, right? That's a very quick way and a very straightforward way to do this training. You can see that the training has just been completed, and this is exactly where the results have been saved to runs classifier train 13. So everything is completed, everything is ready. You can see how simple, how fast it is to train an image classifier just by running this command. Now I'm going to show you another way to do this training, which is using a Google Colab. We are going to use a Jupyter notebook. We are going to use a notebook in a Google Colab in order to train this model. And this is also like a very good way to do it. So let me show you how to do it. So basically you need to go to Google Drive. You need to go to your Google Drive. You need to select New, then More, Google Collaboratory, and this is going to open a new notebook. This is going to open a new notebook in Google Colab, and this is exactly what you need to do in order to use this notebook to train YOLO V8. Now I'm going to show you a notebook I have already created in order to train this model, which is this one. It's called train.ip YMB, and obviously I'm going to give you exactly this notebook in the GitHub repository of today's video, of today's tutorial, so you can just use this notebook if you want. Now I'm going to show you all these different cells, everything that's already written on this notebook, so you understand how exactly to use it and how it works and what exactly you are doing at each step. So let's start with the first step. Another thing you need to do if you want to train this image classifier is to upload all the data with all the images and with all your categories into Google Drive, obviously. For example, in my case, this is where I have my weather dataset. You can see that this directory is exactly the same directory I have over here. Weather dataset. Within weather dataset, there are two directories which are train and bold. If I open this directory, you can see we also have train and bold. So this is exactly the same data as in my local computer. Now this is something very important, because remember to do it, because you need the data in your Google Drive in order to train this model using a Google Colab. This is a very important step. Please remember to upload your data into Google Drive. Now, once your data is in Google Drive, then you need to be able to access your data from the Google Colab. And in order to do that, you need to execute this cell. If I click enter, you can see that now I'm going to be asked if I want to connect Google Colab with Google Drive. And the only thing I need to do is to say I accept. There you can see that it's requesting for my permission. I say connect to Google Drive. And then I select my account, and then basically is to scroll down to the bottom of this page and to click allow. And this is going to allow Google Colab to access all the data you have in your Google Drive. So this is a very important step. Now, something that's very important is that you need to be able to access your data, so you need to know where your data is located in the Google Drive, right? You need to know exactly what's the path, what's the location of your data in Google Drive. In my case, let me show you my Google Drive. You can see that my data is located into a directory. This is my root directory, which is my drive. Then I have another directory which is called Computer Vision Engineer. Then another directory which is Image Classification, YOLO V8, and then data, and then this is where my weather dataset is located. In your case, it's going to be different. Obviously, it depends on where exactly you have uploaded your data. So something you may want to do is just to click this ls. You can say something like ls, and then you say something like content, my G drive, my drive, right? You execute this command, and if I execute this command, you're going to see a very long list of files, which are basically all the files which are in my root directory in Google Drive. And for example, this is where I have the directory which is called Computer Vision Engineer, and if I do ls, you're going to see all these different directories. If I say something like Image Classification, YOLO V8, then this is data train.ipymb, which is exactly this notebook. And then if I say data, this is exactly where the weather dataset is located, right? So do something like that, because you definitely need to know what is the path of your data in Google Colab, right? You definitely need to do it in order to continue to the next step. This is very important, because if you haven't set your data properly, if your data location is not set properly, then YOLO V8 will not be able to train your model. This is very important. So in my case, this is exactly where the data, the weather dataset is located, right? This is the path to the weather dataset. So this is the cell I am going to execute, that this is the value I'm going to save in this value in data directory, in data dir. Now I'm going to continue. Then we need to pip install Ultralytics, which is the library we need in order to train this model, in order to use YOLO V8. Now the only thing you need to do is to execute this cell, and everything will run super smoothly. You can see that we have already completed this process. Now I'm going to continue, and the only thing we need to do now is to execute this cell. And you can see that the code we have in this cell is very similar to the code we have over here, right? Basically, we are running a Python script from a Google Colab. That's all we're doing. So you can see we are importing OS, and also we are importing the YOLO library, we are importing from UltraLiquidix, we are importing YOLO, and then we are doing exactly the same as we are doing before. And this is where we are using the data directory, the data dir variable we have defined over here, right? So this is why it's very important you set this variable properly. So the only thing I'm going to do exactly the same as before. I'm just going to do this training for only one epoch, so we make sure everything's okay. I'm going to press enter, and that should be it in order to do all this training. The first time you execute this training, it may take a little longer because you are downloading all the weights and you are downloading the modules and everything, but after that everything should be much quicker. Okay, so you can see that now the training process is in progress, everything is going super well, and from now on the only thing we need to do is to edit the number of epochs, so we do like a more deeper training. But I will say everything is working super properly. So now let's move to the other cell, so I show you what exactly you need to do once everything is completed. Once everything is completed, the only thing you need to do is to run this cell. So you are going to copy all your results which were saved on this directory. You're going to copy everything on your Google Drive, right? Because remember, you are working on a Google Colab, you're working on an environment which is your Google Colab environment. If you don't do something like this, it's going to be super hard for you to get the data you have just trained, right? To get your results, to get your model, your weights. It's going to be super hard because everything is located in your Google Colab environment. And long story short, it's going to be much simpler and much better if you just do something like this and you just copy everything, all the results which were saved in this directory into your Google Drive. It's going to be much better because it's going to be much easier to download the weights, to download the results, and so on. So now I'm just going to wait a couple of minutes so everything is completed over here, and then I can show you how to copy the results into your Google Drive. Okay, now the training process has been completed and you can see that the results have been saved into runs, classify, train. So these are very similar output to the one we just noticed when we were training on our local environment. Now, the only thing we need to do is to copy everything into our Google Drive, so everything is much simpler if we want to download these results or to do whatever we want. So the only thing I'm going to do is to run this cell and everything will be copied into this directory, which is the same directory where I have my data and where I have my Google Colab, right? Now you can see that everything has been copied already. This is the directory I have just copied. This is the time, this is the current time. So this is the result of the cell I have just executed. And if I go to runs, classify, train, you can see that these are all the results we have generated. This is the CSV file containing many different results, which I'm going to show you in a few minutes, and these are the weights and so on. So from now on, if we want to get this data or if we want to analyze this data, the only thing we need to do is to select runs, and then we just need to click download, and this is going to download all this directory into your local drive, right? You can see everything is being zipping and once everything is zipped, this directory will be downloaded into my local computer, and you can see that this directory has just been downloaded, so everything is working just fine. Now this is pretty much all in order to show you 3 different ways in which you can train an image classifier using YOLO V8. And now let's do the deeper training, right? I'm just going to take this script and I'm going to edit the number of epochs, so we do this training for something like 20 epochs. I have already been doing some tests and 20 epochs is just enough for this dataset, for the dataset I am using in this tutorial, so 20 will be just fine. Now the only thing we need to do is to click on run. I'm just going to run this script as it is, and everything will be exactly the same as before. Everything will be exactly the same, right? We just need to wait until this process is completed. We don't need to do anything from now on, but this process will be executed for 20 epochs. So the only thing I'm going to do is to wait until this process is completed, and once everything is completed, we are going to validate this training process. I'm going to show you how to analyze if all this process was done successfully or not, if you have successfully trained a good image classifier or not. So I'm just going to pause the recording here and I'm going to fast forward until this is completed. Okay, so the training process has been completed, and now let me show you all the results which were saved here into runs, classify and train 14. Now let me show you this directory, this folder in my local computer. If I go to runs, classify and then train 14, this is where all the results have been saved, and this is everything we're going to analyze now. Now we're going to decide if the model we have trained is a good model or not. We are going to decide if this is a model we can use or not. So you can see that there are two files, arg.yaml, results.csv, and another directory called weights. Let's start by args.yaml. If I open this file, you can see that this is something like a config file, and this is exactly the entire configuration file which we have just used in order to train this model. This is very important because this is a super comprehensive list of all the hyperparameters we have used in order to train this model. And for example, the only parameters we have specified are image size, number of epochs, and then data, the location of the data we have just used. And you can see that we have a keyword which is data, then epochs, then image size, and then we have many other keywords as well. This is very important because these are absolutely all the keywords we have used. We have used all these default values which were set for all these different keywords, and this is important in case we want to train a new model and we want to make some changes into some of these hyperparameters. Now let me show you the other file, which is the results.csv file. I will say this is much more important. This is like the file containing all the information we need in order to decide if this is a good model or not. And you can see that we have many different rows, each row for one of our training epochs, right? We have trained this model for 20 epochs, and you can see that we have 20 rows for each one of these epochs. And for each one of these rows, we have all this different information, and we are going to focus on these three values, on the training loss, the accuracy, this is the accuracy of the validation set, and then also the validation loss, right? These are the three keywords in which we are going to focus on this tutorial in order to validate this model. And I'm going to give you like a very quick tip, like a very quick way in order to analyze this training process, which is make sure the training loss and the validation loss are going down through this training process, and also make sure the accuracy goes up. And I know you're thinking, hey, this is a very simple way to analyze this process, Felipe. Yeah, I agree with you. This is a very simple way, but at the same time, it's very robust. This is like a very simple, but at the same time, very powerful way to decide if you have a good model or not. Now, we can analyze all these numbers, but I think it's going to be much better, and it's going to be much prettier if we make a plot with all these numbers, right? Because we have epochs in this column, in this coordinate, and we also have all these different values, and we can definitely plot these values across all these different epochs. So let me show you a Python file I have created, and this is exactly what this Python file does. This file is called plot metrics, and if I open this file, you can see that it basically we need to set a path to our results.csv file. In our case, I'm going to set it to train 14, and you can see that this is runs, classify, train 14, and then results.csv. And then this is only like some logic, some very simple logic to take all the data from this results.csv file and to do some plots with it, right? That's all we're doing. We're just taking the data and doing some plots, and this file will be available in the GitHub repository of this project, of this tutorial. So you can definitely take this file and you can just use it to plot your functions as well. All I'm going to do now is just press play, and you can see that if we wait only a few seconds, we get all these two plots, right? And this is all the information in our CSV file, right? Everything I show you over here, it's summarized on these two plots. So this is exactly what I mean with make sure your loss is going down. This is our loss in the training set and in the validation set. In the training set, we are plotting the loss in blue, and in the validation set is red. And you can see that in both cases the loss is going down, right? Which is exactly what we expect. It's exactly what we want. Now, this is a very simple way to analyze this process, but trust me, this is also a very powerful way, right? This is something that's very healthy. Something that looks like this is very healthy. And then for this other plot, which is how the validation accuracy evolves through this training process, you can see that the validation accuracy goes up when we increase the number of epochs, right? You can see that starting from the 10th epoch or so, everything starts to be like somehow idle, right? We are not really gaining a lot of accuracy from here, but we are not losing accuracy either, right? We are just in something like a plateau. And this is exactly how a validation accuracy plot should look like, right? We are starting from a very low value and then we are just increasing our accuracy until we reach a very high value of accuracy, right? This is like a very healthy training process. Now, obviously, we could make this process even better if we just if we just change some of these parameters, and if we do like a more customized training, I'm sure we will be able to have a better model, right? Because remember, we are using all the default values. So as it usually goes, if we make like a more customized training and we have different and we try different AP parameters and so on, we should be able to get like a better model. But obviously, we are not going to do it in this tutorial because I just want to show you like the end-to-end on how to train this image classifier. But remember, you could do it even better than this if you make like a more custom model. So this is pretty much all for analyzing these plots, which are the validation accuracy and the loss function in order to validate your training. And then it's like the this directory, which is the weights directory. You can see that this directory is called weights, and this is exactly where the models will be saved. This is very important because you have trained a model and now obviously you want this model in order to use it in your images, in your data. And this is exactly where you're going to find this model. And you can see that you have two different files. One of them is called last.pt and the other one is called best.pt. Now let me explain exactly what these two files are and exactly what they mean. So remember how this training process works, right? Remember that you have a model, you have a deep learning model, which is comprised of many different weights. And the way it goes is that at the end of every epoch, right? At the end of the first epoch, of the second epoch, of the third epoch, and so on, you are updating the weights of your model. You are updating the weights of your architecture, of your deep learning model. So the way it works is that at the end of every epoch you have a model available, which is a model you have trained so far with all the process you have followed so far. So last.pt means that you are taking the model which was the result of the last epoch of your training process, right? Remember, at the end of absolutely every single epoch, you have a model available, you have a model which you can definitely use if you want to in order to produce your inferences and so on. So last.pt only means that you are taking the last model, the model which was produced at the end of your training process, at the end of the last epoch in your training process. So at the end of the 20th epoch in our training process, we are producing this model which is last.pt. But you may wonder, hey Felipe, yeah, it's great because at the end of our training process our accuracy is something like a 93%, right? A 93% it's a very good accuracy. But if we take the accuracy, if we take the model at the end of the 16th epoch, for example, our accuracy it's higher, it's a 94.9%. Maybe it makes more sense to take that model instead, right? Because we have an even better accuracy, we have an even higher accuracy. And if you ask me something like that, I will say, yeah, you're perfectly right. You're super right. That's a very valid argument. And that's exactly what the best.pt model is, right? We are saving the weights of the best model in our entire training process. So if we look at our data, the best model in our training process is this one, if I'm not mistaken, right? It's the model we produced at the end of the 16th epoch, and our accuracy or validation accuracy was 94.9%. So this is definitely higher than the accuracy we got at the end of this training process, which was a 93.5%. And if we will take the best model we have produced in the entire process, in the entire training process, then we will definitely need to take this model. So this is exactly what best.pt represents, is the best training, the best model you have trained in your training process. And if you ask me, what I usually do is taking the model which was produced at the end of this training process, right? What I usually do is taking the last.pt file, because I consider that this is a model we have produced at the end of the training process. In this model, we are summarizing much more information, right? Because we are considering much more data, we are considering much more everything. In all this training process, many things are going on, many things are going on. And remember, there's a lot of randomness in this training process. So me personally, I consider that if I take the model which was trained at the end of this process, is a much better option than if I choose another one. If I choose like the best model or the model which I got the highest accuracy, but it's not the last model. That's what I usually do. I usually take the last model which was produced at the end of the training process. But if you want to take the best model, if you want to take the best.pt, it also makes sense, because you are taking the model which produced the highest accuracy, right? So you can do either one of them, and I think it's a very good option. That's why you have these two files, because you can use one of them or you can use the other one. And I will say that making like a very like the best decision on which model to use depends on many different variables, depends on many different things, depends on your data, depends on your problem, depends on your use case, depends on your training process, depends on many different things, which is the best option, right? So remember, you have these two models, and it's all up to you. It's all up to your specific project, and it's all up to your preferences which model you want to use, right? If the best model which you have produced through the entire training process, or if you want to use the last model, the model which you have produced at the end of your training process. So now let's go back to PyCharm, because now it's time to make our inferences. Now it's time to predict new samples, right? We are going to input an image, and we're going to use our image classifier in order to predict which category this image belongs to. So let me show you how to do it. I'm going to import from Ultralytics, import YOLO, and then let's go back to this page, because now we are going to move to the predict section, and the only thing I'm going to do is to copy this sentence, going to paste it here, and then I'm going to specify the path, the absolute path to the model which we have trained, right? We don't really need to make it like the absolute path, we can use the relative path. So I'm going to do something like this, right? Sorry, something like this. So this is the path to the model we have just trained, right? This is the last model which we produced at the end of this training process, and this is the model I'm going to use in order to show you how this works. And now let's copy this additional sentence, which is results equal model and the model path, the image path. Right? You can see that you can use an image in your local computer, in your file system, or you can also use something like an URL. For example, in this case, in this example, which is in the YOLO V8 website, you can see that the example is using an URL, and this is also going to work. So in my case, I'm going to use an image in my local computer. I'm going to use one of the images I used for training, because I only want to show you how this works, but obviously you can use whatever data, whatever image you want. So this is the image I am going to use. I'm just going to inference this image, right? Which is the first image in my sunrise category data. So this is going to be something like sunrise1.jpg. And this is pretty much all. So these are the results. The first thing I'm going to do is just trying to run this code, and let's see what happens. Everything should run smoothly, but this is where we're going to see if we have any error or something like that. We may need to wait a couple of seconds, and everything seems to be working fine because we didn't get any error. So what I'm going to do now is I'm going to print results, because I want to show you a couple of things. So this is the entire information we are getting when we are printing results, right? You can see that this is a lot of information. We have these probabilities, which is the inferences we are making. This is exactly the result of applying our image classifier, and then we have a lot of information. Another object or another result which is very important is this one, which are the names of the categories we have just trained our image classifier on, right? You can see that this is cloudy, rain, shine, sunrise, and also you can see that we have different integer values for each one of these categories. So this is something like a dictionary, because we are going to have a result from applying our image classifier, and then with this result, which is going to be an integer, we are going to call this dictionary, we're going to call this object, because we want to know exactly what's the name of the category we have just inferenced, right? So this is how we're going to do it. I'm going to call another variable which is going to be names, something like names dictionary, names dict, and this is results 0, because results is a list. In this case, we only want to access the first element because we are only predicting an individual image, so this is the element we want. And then we are going to call dot names, and that's pretty much all. Then I'm going to define another variable which is props, and this is results 0.props, and this is the probability vector of all the different categories we are trying to classify, right? So we are going to have a length 4 array with the probabilities of the different classes we are classifying, right? So let me show you how props looks like. I'm going to print props, and I'm going to do something else. I'm going to say to list, so we make this object into a list. We are using YOLO, which is based on PyTorch. So if we don't do this, if we don't call this method, we will be working with a torch object, right, with a tensor. So we don't really want to do that, so that's why I'm doing this to list. Now I'm going to print props, so I show you how it looks like, and I show you how to continue from here. Okay, you can see that this is a result we got from printing props, and you can see that this is a list with 4 elements, 1, 2, 3, and 4, and each one of these elements are the probabilities of this image to be one of these categories, right? Let's print the names too, so we have all the information in our screen. I want to show you something, so I'm going to print. Sorry, this wasn't names, this was names dict. And now let's wait a couple of seconds. I want to show you not only the probabilities but also the class names, so it's a little more clear what exactly I'm going to show you now. So this means that this number is the probability for this image to be cloudy, right? This other number is the probability for this image to be rain. This other number is the probability to be shine, and then this last number is the probability to be sunrise. And you can see by the values that we are definitely classifying this image as sunrise, right? Because this is almost a 1. This is almost like a super confident and absolutely confident classification. So this is exactly the category we are classifying for this image, and this is how to make sense of this information. So what I'm going to do now is to print names dict, and then I'm going to call mp.argument_argmax, and then I'm going to input the probability list I just showed you. And obviously I need to import numpy as mp, otherwise it's not going to work. And basically what we are doing here is that we are looking at this list, the one containing all of our probabilities. We are taking a look at the maximum number, which in this case is this one, and we are taking the index of this maximum number. So in this case, this is the first element, so this is the index 0, this is 1, this is 2, and this is 3, right? So from this from calling mp.argmax_props, we are getting 3, and then we are calling the third element of the nameStick object. So we go here and we see that 3 belongs to the sunrise category. And if we look at this image again, we are going to see we are in fact plotting a sunrise. Let me show you. So everything seems to be working fine, and this is going to be all for today. This is exactly how you can train an image classifier using YOLO V8 in your own custom data, and this is going to be all for this tutorial. So this is going to be all for today. If you enjoyed this video, remember to click the like button and also remember to subscribe to my channel. My name is Felipe, I'm a computer vision engineer, and these are exactly the type of projects I make in this channel. So this is going to be all for today, and see you on my next video. Hey, my name is Felipe and welcome to my channel. In this video we are going to train an image classifier using TensorFlow 100% online without using any code whatsoever. We're going to use Teachable Machine, which is a tool made by Google, and we're going to train a super robust image classifier in only a few minutes. Now let's get started. So let's start with this tutorial, and this is exactly the website we are going to use in order to train this image classifier 100% online with no code whatsoever. Now let me show you the data we are going to use today. We're going to use exactly the same dataset we used in one of my previous videos where I show you how to train an image classifier using YOLO V8. We're going to use a weather dataset, and these are the 4 categories we have in this dataset. The first category is cloudy, and you can see how the images look like. Now if I go to the other category, it's rain, and you can see that these are pictures of super rainy days. Now if I go to shine, which is the third category in this dataset, you can see that in each one of these pictures we have the sun, which is super bright, super up in the sky and super huge. And now the last category is sunrise, where we have pictures of many sunrises. So this is exactly the data we are going to use today, and remember we have already used this dataset in one of my previous videos. Now let's go back here. You need to go to teachablemachine.withgoogle.com. This is exactly the URL for this website, and once you are here you need to press get started. Let me show you how simple and how straightforward this process is. It's going to be super quick, super simple, super straightforward, and in only a few minutes we will have a model, an image classifier, which we trained 100% online with no code whatsoever. Now you can see that you have 3 different options, and we're going to select image project and then standard image model. The first thing I'm going to do is I'm going to name my classes. I'm just going to name them correctly. One of them is cloudy, the other one is rain. Then I'm going to add 2 additional classes. The classes are named shine and sunrise. And once I have created my 4 classes and I have just named them all properly, I am going to upload my images. So I'm going to click in upload, choose images, and now I'm going here to the weather dataset, the train set. I'm going to select all my cloudy images, and then I'm just going to wait. And that's it. That's how simple and how easy it is to load all the data into each one of these categories. I'm going to do exactly the same for the rainy category. I'm just going to select all the rainy images. I'm going to press enter, and that's it. Now I'm going to do exactly the same for the other 2 categories. For the shine category, it's something like this. And then for the sunrise category, we are going to do exactly the same. And that's pretty much all. That's pretty much all it takes to load all of our data, to name all of our categories properly, and to take all of our data into this platform. That's exactly what we need to do, and that's how simple this process is. Now the only thing we need to do in order to train this model is to press this button, train model. You get the idea, right? You get the idea how simple and how straightforward everything will be today. But before training this model, I'm going to make a very small adjustment. I'm going to press this tab over here, which is advanced, and I'm going to change the number of epochs. I'm going to train it for 10 epochs, so we can see how we go from there, right? I'm going to train it for only 10 epochs. I'm going to press train model, and that's it. The only thing I'm going to do now is I'm going to wait. I'm going to wait until this training process is completed, and this is going to be super amazingly quick, right? This is going to be a very quick process, a very quick training process. Now it's training, and you can see that this is the first epoch, the second epoch, the third epoch, the fourth epoch, and so on, right? The fifth, the sixth, the seventh, and you can see how fast everything is going. In only 15 seconds we have trained our model. In only 15 seconds we have trained our image classifier. Now it's asking for permission to use my webcam, because that's one of the ways in which you can make predictions by using your webcam, but we are not going to use the webcam in this tutorial. Now, the first thing I'm going to do before making our predictions, before making our inferences, is look under the hood. I'm going to press this button, because if we have trained an image classifier, the first thing we need to do, if we have trained absolutely any type of machine learning model, the first thing we need to do is to validate this model, is to take a look how this model performs, right? That's exactly the first thing we need to do with a machine learning model before using this model. Now, if I look under the hood, if I look at these plots, this is the accuracy per epoch and this is the loss per epoch. Take a look that now we have two functions, right? We have a function in blue and a function in orange, and we have exactly the same here for the loss functions. And although we have uploaded only the training data, we have uploaded only one dataset, we haven't specified anything as a validation dataset or as a test dataset. It seems Teachable Machine, it seems this website internally somehow splits the data into a training set and a test set. It seems this is done internally because we haven't specified absolutely anything, because you can see we have two different functions. One of them is accuracy and the other one is test accuracy, and for the loss function we have exactly the same loss, and then we have test loss. So it seems this website internally splits the dataset somehow, and now we have two datasets, the training dataset and the test dataset. And let's do like a very simple validation process. Let's validate this training process in a very simple way, the same way we did in my previous tutorials. If you watched my previous tutorials, you will remember I always say make sure your loss function is going down. If your loss function is going down, it's likely everything is going well. Make sure the loss function is going down both in the training set and also in your validation set. And if we look at this loss function, you can see that in the training set everything seems to be going well. Everything it's going down, so everything seems to be going super well. But in the validation set, or actually in the test set, you can see that the loss function seems to be somehow stuck, and also it seems to be going up, slightly up, right? It seems to be going slightly in the up direction, and this is something I don't like about this training process. This is a situation that I don't like. Now, if we look at the accuracy, you can see that although both accuracies, the training accuracy and also the test accuracy, both of them are going up, you can see that the training accuracy is going up a lot. We are getting a 100% accuracy in the training set. And that's hardly ever a good situation, because if you are getting that high of an accuracy in your training set, it's usually a sign that you are overfitting your training to your training data. So that's hardly ever a good sign. I don't really like having such a high performance in the training set. And if I look at these two plots, I can see that we are definitely overfitting to the training data, because the loss function in the validation data is going up, and also we get a 100% accuracy in the training data. So this means the model is overfitting to our training data. So what I'm going to do now is I'm going to do a much shorter training, and I'm going to stop this training around here, which is around the moment, around the time the validation loss started to go down, right? It started to go up. So I'm going to do this training for only 3 epochs, and let's see what happens. So I'm going to press train model again, and now we're going to wait until we train a new model, and let's see how this new model performs. Okay, so this is the performance on the new model we trained. You can see that for the loss function, now both of our loss functions are going down, right? The training loss and the validation loss or the test loss. And for the accuracy, we got a very similar accuracy in both of these sets. And for the training set, we are not getting a 100% accuracy, so everything seems to be better now. Now, we are just going to keep this model, and now I'm going to show you how to make predictions, right? How to take this model in order to make predictions. We have 2 ways to do it. We could do it on the same platform, we could do it 100% online, the same way we train this model. We could do it using our webcam, but what I'm going to do is I'm going to do it I'm going to upload a file. This is one of the ways in which we could make our predictions. So this is how I'm going to show you how to do it first. I'm going to my validation data. This is my data, which is my local computer. This is completely unseen data for my algorithm, for my model. So the model haven't seen this data before. And you can see that we are predicting this image as rain with a 99% score. So everything seems to be going well with this model we just trained. Now, this is one of the ways in which you can make predictions using this model. The other way is by going to export model, and here you have three different ways to use this model. You can use it in TensorFlow.js, you can use it as a TensorFlow.js model, so you can just put this model into something like a browser using JavaScript, and you can definitely use it from there. You can take this model as a TensorFlow model and use it from a Python script. For example, I will say this is the way we are most familiar with in this channel because we usually work with Python. And you can also take this model as a TensorFlow lead model and use it from a mobile device. You have these three ways to make predictions with your model, and I'm going to show you how to do it using TensorFlow. You can see that not only we can export this model into these three formats, but we also have something like a code we can use in order to make these predictions. So we have already all the code we need, and we know exactly what we need to do in order to make our predictions. This is how simple and how straightforward everything is using Teachable Machine. Now let me show you. I'm going to download my model. I'm going to download this model as a Keras model. And then this says converting model once everything is converted, and it's just going to be downloaded. And in the meanwhile, I'm going to copy and paste. I'm going to copy this code and I'm going to paste it in a Python project I created for this tutorial. So the only thing I'm going to do is going to main.py. This is a file, a Python file I created in a Python project, and I'm going to press paste. And that is it. And that's absolutely all I'm going to do. I'm just press copy and then I press paste. So I'm pretty much not doing absolutely anything, you may notice. And this is how simple everything is using this website. Now, if I go back here, you can see that now. And we have two files. One of them is called kerasmodel.h5 and the other one is called labels.txt. Now, this is the model we have downloaded, and what I'm going to do is I'm going to take these two files and I'm just going to locate this file in the file system, in my file system for the Python project I have just created, right? You can see that this is the main.py file I have over here where I have just pasted absolutely all of my code, and this is where I'm going to take these two files which represent the model we just trained using Teachable Machine. Now, this is just going to take a couple of seconds. You can see that now these two files are in my file system, are in my local computer. And now let's go to Python because everything is pretty much ready to be used. But we need to do like a very, very small edit, which is, you can see this file name over here. It says kerasmodel.h5. Everything is okay, but you can see that this is a capital M. The M is in uppercase. We need an M which is lowercase, right? I don't know why we have this typo, but we do. If you take a look at the model you have just downloaded, you can see that this file, it says kerasmodel.h5, but it's in lowercase. So that's the only edit we need to do, and everything else should work just fine as it is. Now I'm going here where it says image path, and here I'm just going to copy and paste the path to one of my images in the validation set, right? So I'm going here, val, I'm just going to choose one of the shine images. I'm going to choose shine 1, so I'm going to do something like this on shine1.jpg. And now the only thing I'm going to do is I'm going to press play, and that's it. And that's all we need to do in order to make our predictions using Python with that TensorFlow model we trained using this website. That's how simple everything is. Now, obviously, while we are waiting for our predictions, everything is just completed. You can see that we are getting shine exactly as we should with a 99.4 confidence score. So everything is amazing. And what I was going is that remember to install this project dependencies, remember to install all these packages, because otherwise it's not going to work. You can see here at the top we are using Keras, Pil, and NumPy. So please remember to install all these packages, which are Pillow, NumPy, Keras, TensorFlow, and also Scikit Learn, because we are going to do another edit. Because I think it's very interesting. We have this code in order to make predictions on individual images, so we get an idea of how this performs on an individual image. But let's see how it performs on the entire validation set we have over here, right? Remember, in one of my previous tutorials I showed you how to make an image classifier using YOLO V8, and we used exactly the same data. So let's just compute what's the accuracy on the entire validation set, so we can compare this model we trained with the model we trained in one of my previous tutorials. And in order to do so, I'm going to just make a few small edits. The first one is going to be define a new variable, which is root directory, and this is where I'm going to specify the path to the validation dataset. So I'm just going to press paste, and that should be all. Okay, so this is root directory, and now I'm going to iterate in all the directories within my validation data, and then I'm going to iterate also in all the images within each one of these directories. And this is how I'm going to do. For dir in os list dir root directory, obviously I need to import OS, otherwise this is not going to work, so import OS. And then for j in os.listdir os path join root directory dir, and that's pretty much all. Okay, and then I'm going to define another variable, which is image path, and this is os path join root directory dir and j, and that's pretty much all. Now I'm going to edit this value over here, and I'm going to change it by image path. And now we are reading the image path, we are reading absolutely every single image in each one of our directories in the validation data. So the first thing I'm going to do is to make sure this executes properly. And once we make sure everything runs super smoothly, I'm going to make some additional edits. But for now, let's see if this is just okay, if this runs super smoothly. Okay, we are getting predictions, so everything is just fine. And now what I'm going to do is I'm going to save all of my predictions into a list. So I'm going to create a list which is called predictions, and then I'm going to create another list which is called labels. And this is where I'm going to save all my predictions, and this is where I'm going to save all my labels, right? Now I need to import an additional library, an additional function, which is from sklearn.metrics import accuracy score, right? Because I am going to call this function in order to get the accuracy score of this model in absolutely all my validation data. And by calling this function, it's going to be super straightforward. Now I'm going back here, and what I'm going to do is I'm going to append. This is the index, so this is the value we need. This is the integer we need in order to have our classification, in order to have our predictions. So I'm just going to say predictions.append index. Now I need to append the label for these images, and in order to do so, let me show you something first. These are our class names. If I go back here to this project file system, to this project directory, you can see that if I open this file, is the labels.txt file we have just downloaded from Teachable Machine. And you can see that we have 4 values: 0 cloudy, 1 rain, 2 shine, and 3 sunrise. So these are the category names, and these are the indexes, right? So once we are saving all the data into predictions and into labels, we need to make the predictions and the labels into this format, right? We need to append these values. Now, our labels, currently the way we are iterating all these directories, our label is here. It's in the directory name, right? if I go back here to the validation data, you can see that to the validation data, to the root directory of the validation data, you can see that our labels are actually the directories names. So we need to make some process, we need to make some function or something to take this name and to return this index, right? It's very straightforward, it's very easy, but we need to do it first. Now, this is how I'm going to do. I'm going to print class names. I'm going to print this variable, which is actually the this variable contains all the information we can see over here, but let's see exactly how this information looks like. So I'm just going to press play, I'm going to print this variable, and then I'm going to continue. Okay, and now I'm just going to press stop. You can see that this is the variable we print, and this is how it looks like, right? So we have 4 elements. This is a list with 4 elements. They are called, the elements are called the 0 cloudy, then 1 rain, 2 shine, 3 sunrise, and then for each one of these elements we also have a new line character, right? That's very, very important. So I'm going to create a variable, I'm going to create a dictionary, which is something like category to index, right? This is going to be the name, and this is going to be a dictionary. Then what I'm going to do is I'm going to iterate in all these elements in this list. So this is going to be something like for class name in class names, and then I'm going to say something like category to index. First I'm going to say something like class name dot split, and I'm going to split it by the space, right? Because I want to get these two values, the index in one variable, and then I want the category name in the other variable. So I'm going to say something like this, and this is going to be index and name, right? So I'm going to say something like this, and then I'm going to say that name is equal to name except the last element, right? Because we get that the last character is a new line character, and we don't really care about that character. And now I'm going to say this, category to index name equal to index, right? So now with this new variable we have just defined, it's super easy to do something like this. I'm going to labels append category to index dir, because this is the label of the image we have just read over here. So this is how simple this will be. Now I'm just going to press play to make sure everything executes properly and to make sure we don't have any error. And then it's going to be super easy, because the only thing we need is to call accuracy score predictions labels, right? But let's take it one step at a time. Let's see if this executes properly. Everything seems to be okay. And now let's see what happens. I'm going to print the accuracy score on the validation data with the model we just trained using Teachable Machine. Let's see what happens. Okay, so we got an error. So I think I know what's the problem. And this is the problem that we need to say this is int, right? Because we need to compare integers to integers, otherwise this is not going to work. Now I'm going to press play again and see if that was the problem. Okay, so now I didn't get any error, and this is the value we are looking for. We are getting a 98.6% of accuracy in our validation data with the model we trained. And remember, this is completely unseen data for this model. We didn't use these images in order to train this model. So this is amazing. This is an amazing performance. So this is going to be all for today. My name is Felipe, I'm a computer vision engineer, and these are exactly the type of projects I make in this channel. So if you enjoyed this video, I invite you to click the like button, and I also invite you to subscribe to my channel. This is going to be all for today, and see you on my next video. Hey, my name is Felipe and welcome to my channel. In this video, I'm going to show you how to build and sell your own computer vision API. We will be deploying a computer vision model that detects ships on satellite images. This is a very important use case of computer vision with applications in illegal phishing detection and naval security. We will be working with Python, FastAPI, YOLO V8, AWS, and we will offer this API for sale in Rapid API. I'm going to show you every single step of this process, from how to make predictions with your computer vision model, how to build the API in your local environment, how to deploy it in a server, and how to set everything up in Rapid API. At the end of this video, you will have the knowledge to deploy your own computer vision model and to make money from it by selling a monthly subscription to an API. And now, let's get started! In this video, I'm going to show you how to build and sell your own computer vision API. And now let me show you the image classifier we will be serving through this API. Let me show you the data I used to train this image classifier. So we're going to be using a binary classifier which is going to take a satellite image and is going to classify this image into one of two categories. It's going to classify every single image either as sheep if the image contains a sheep, or as no sheep in any other case. So this is exactly the image classifier we will be using today, and I built this classifier using YOLO V8. And if you want to know more details on exactly how I trained this image classifier, I invite you to take a look at other of my previous videos where I show you the entire process of building an image classifier using YOLO V8, and I'm going to be posting a link to that video over there. And now let's go to PyCharm, because now it's time to start working on this API. We are going to build this API locally on our local environment, and then we are going to deploy this API in a server, and then we are going to publish this API in Rapid API. But let's take it one step at a time. So this is PyCharm. I'm going to click here on New Project. I'm going to select the directory where I want to create this project, which in my case is this one, and then Image Classifier API. And I'm just going to click OK, and I'm going to leave everything else in the default values, and then I'm going to click here on Create. And I'm going to create from existing sources. Okay, so the project has been created, and now let's install the dependencies, the requirements, the Python packages we need in order to make this API up and running. I'm going to click here on File, then Settings, then I'm going to click here on Project and Python Interpreter, and I'm going to click on this plus button. I'm going to install 3 packages. The first one is Ultralytics. I'm just going to select Ultralytics. I'm going to install package. Then I'm also going to install Fast API, install package, and then I also need to install this other package which is called Ubicorn. So I'm going to install package as well, and that's pretty much all. I'm going to get back here, I'm going to click OK, and we have to wait a few minutes while all the packages are being installed, but in the meanwhile we can start working on this project. So I'm going to click here on File, New, Python file, and I'm going to name this file main.py. So this is the main file in which we will be working today, and the first thing I'm going to do is to import from Fast API, import Fast API. And I'm going to define a new variable which is called app, and app will be Fast API. Okay. And in order to take it one step at a time, let's start defining the method we are going to call every time we want to classify an image, every time we call this API. So this method will be called classify. And for now, let's just assume we are going to input a variable which is called image URL. We are going to make it a little better and a little nicer later on, but for now, let's just assume we are taking as input a variable which is called image URL. And then, in order to take it one step at a time, let's just return an empty dictionary for now, and that's pretty much all. Okay, and we need to do something here, which is we need to define this a post method, which we are going to do like this, and this is the method we are going to call when we call the classify endpoint, right? So this is the most basic structure of this API, and now let's take it one step at a time and let's build everything else. And I'm going to make another import which is from Ultralytics, import YOLO, and then I'm going to define a variable which is molpath. And this is the location of the model we are going to be loading with YOLO V8. And the model is located in my local directory, in the same directory in which I have created this Python project. And this is the model we are going to be loading now, which is called shipclassifier.pt. So this is my current directory, shipclassifier.pt, and then I'm going to define another variable which is model, and model will be YOLO, and I'm going to take as input the model path, and that's pretty much all. Now let's get back here to this function to classify, and let's see exactly how we can make predictions using this model. We are going to assume image URL is the URL to the image we want to classify. So this is how we are going to do. I'm going to call model, and then I'm going to input image URL. This is going to be output. I'm going to name this as another variable, which is output. And then I'm going to access the first element of this list, because we are only classifying only one image, right? We are classifying one image only, so we are just going to access the first element from this list. Then I'm going to call output.props.data.toList, and this is going to be our predictions, right? This is going to be a probability vector with our predictions. We are going to have the probability of this image being each one of the classes we are interested in, right? And in order to move one step at a time, let's see exactly how this looks like. So I'm just going to print pred, and I'm going to launch this API, and let's see what happens. So I'm going to get back here to the terminal, and I'm going to execute python m ubicorn main app, and let's see what happens. No model name ubicorn. It seems there's something wrong with our install, so let's get back here to settings, Python interpreter plus, and I'm going to search for ubicorn. And now let's get back to the terminal. I'm just going to execute the same command again, and now let's see what happens. I'm going to wait a few seconds, and you can see that now everything seems to be working just fine. I'm going to click here. Let's see the API we have just launched. I'm going to access this endpoint, which is docs, and this is a built-in feature from Fast API. This is going to make the entire process of testing this API much simpler, much better. And now let's click here and try it out. Let's see what happens. I have already prepared a couple of images we are going to use as an example in order to test this API, and let's see what happens with this image. You can see that this is the image of a sheep, and this is the image of something which is not a sheep. This is the image of a dog, and dogs are not sheep, so this is going to be a very good example in order to test the no sheep category. So let's start with this image, and I'm just going to get back here. I'm going to paste the image URL, and I'm going to execute this API, and let's see what happens. Let's get back to a terminal. Let's get back to PyCharm, because we want to see exactly how this probability vector looks like. And you can see that this is the output we get, and this is exactly what we are printing over here. This is our predictions, right? We are going to further process this variable. We are going to continue with our processing, so we extract what's the category this image belongs to. So for now, let's just stop this API. This was only an example in order to show you how pred looks like. Now let's call np.amax, and we are going to input this variable, right? We are going to input this vector, and this is going to be the prediction index. Now let's cast this to integer just in case. Now let's call pred.names, which are all the names, all the different categories of this classifier, and let's access this index over here, and this is going to be our prediction, right? So let's see what we can do. Now we can start preparing this dictionary, which is the dictionary we are going to get back to the user, the dictionary we are going to return to the user. And this is what we are going to do. I'm going to create a key which is called prediction, and prediction will be this, right? This is going to be the class we are predicting. Now let's see exactly what's the confidence value for which we have predicted this class. So I'm going to create another variable, another key, which is called score, and score will be something like pred and then pred index, right? And that's pretty much all. This is a very small mistake. This is not pred.names, but this is output.names, right? Because we want to access the names of the model we have trained. So this is exactly how we need to do it. And also let's return to the user the same image URL we have received, right? The user is already familiar with this image URL because it's the same URL we have received, but let's just get this back to the user as well. Now I'm going to execute this script again. I'm going to execute this API again. And now let's see what happens once I execute exactly the same image. I'm going to click on execute. And we got an error because name NP is not defined. Yeah, obviously. I forgot to make this import, which is from, import numpy as NP. Okay, now everything should be okay. I'm just going to launch this API again. Okay, now I have executed the same image again, and something is wrong because we have classified no sheep, and this is not right? You can see that this is obviously a sheep. So let's see what's the problem. And I think this is error. Okay, we are getting the we're calling Amax, but this is not Amax, this is argmax, right? Because we want to get the argument of the maximum value. So I think now we are going to be just fine. I'm going to launch it again. So we are moving super slowly. We're moving one step at a time, but this is only to make sure we are making things right? So I'm going to get back here to the API and I'm going to execute exactly the same image again. Okay, and you can see that now we are predicting sheep exactly as it should be. This is the prediction value, this is the confidence score for this prediction, and this is the same image URL the user has input into this API. So we are almost there. We have almost completed this process, this API, but we still need to add some extra details. So let's get back to PyCharm so we can continue working on this API. But we are almost there. These are just some very small details we need to do in order to make everything look much nicer and in order to make everything much better. But the entire structure is completed. So I'm just going to stop this process because we don't really need the API for now. And now let's do something else. You can see that we are taking as input the image URL and we are just defining this as we usually do in Python, right? But we need to do it slightly different because this is an API and the way we need to do it in this case is slightly different, and this is how we are going to do it. We are going to import from Pedantic, which is another library we are going to be using now. We are going to import base model. And then we are going to define a class which is image, and this class is going to be a child from base model, and we are going to define a field which is image URL, and this is going to be a string, right? So we are defining this class, and this is very important because I'm going to show you exactly why this is important in a few minutes, but for now just follow along. So now I'm going to get back here to this function, and instead of getting an image URL, instead of receiving an image URL, we are going to be receiving an image, and now this image URL is going to be equal to image URL, right? We are going to be accessing the image URL field from this object we have received over here, right? You can see that this is pretty much the same. We are going to continue working on this image URL from now on, and everything is going to be exactly the same, but this is how we need to do it in order to make everything much better, and you're going to see why in a few minutes. Just in order to make absolutely and 100% sure everything works properly, I'm going to execute the API again, and let's see what happens. So I'm going to get back here and I'm just going to execute. I'm going to refresh because now we need to input the image URL in a slightly different way. You can see that now we have these fields over here, and if I click on try it out, we need to edit the request body, and this is how we're going to do. We already have this variable which is image URL, and I'm just going to edit the value of image URL. Okay, and you can see that we are getting exactly the same output. We are classifying sheep, this is the confidence value, and everything is just exactly the same as it used to be a few minutes ago. And now let's get back to PyCharm, because there's something else we need to do in order to make this 100% ready in order to continue to the next step in this process, which is we need to enable cores. This is a very important thing to do when preparing an API, when making an API public, when publishing an API. It's very important we enable cores, so we make sure this is available through the entire world, right? Absolutely anyone in anywhere could access this API. So this is what we are going to do now. We are going to enable cores. And I have already prepared the code we need to add here in this script in order to enable CORS. So I'm just going to copy and paste these values, and I'm also going to copy and paste this import over here. Okay, you can see that we are importing this object, and then we are just calling this function from our application, and that's pretty much all. Obviously, we need to paste this value after we define this variable, otherwise it's not going to work. And that's pretty much all, right? So just keep in mind, this is something that's very important when working with an API. Let's see if everything works properly. I'm just going to execute this API again, and let's see if we can just get exactly the same return as we got a few minutes ago. I'm going to refresh, and I'm going to try it out. I'm just going to copy and paste the same URL. I'm going to make it like this. I need to do it with these double quotes. I click execute, and in a few seconds you can see that we should be getting exactly the same output as we got the other times, right? We are predicting ship, this is the confidence value, and everything works just fine. And we are ready. We have completed this process. We have completed the first step in this process, which is setting up this API in our local environment. Now let's continue to the next step, and I'm going to show you how to deploy this API in a server. And now let's get back to my browser, and I'm going to show you how to deploy this API in a server in AWS. You can use pretty much any other server you want, but I'm going to show you how to do it with AWS, and I'm going to be following these instructions I have over here, which will be available in the GitHub repository of today's tutorial. So the first thing you need to do is go into AWS to this website over here, and then you need to log in into your account. Once you are logged into your account, you are going to see something like this, which is the AWS Management Console. And you need to select EC2. We are going to launch an EC2 instance, and then I'm going to show you exactly how you need to do it. You need to click here on Launch Instance. I'm going to call this instance something like Computer Vision API Server, something like that will be just fine. And I'm going to select Ubuntu. Then if I scroll down, then the instance type, this is going to work in pretty much any instance type you want, but I'm going to select the T2 large. This is the instance type I'm going to select for this project. Then if you do not have a key pair, you need to create a new key pair, but I already have a key pair, so I'm just going to select my key pair, and then I'm just going to continue. This is very important. You need to edit this number because 8 GB are not going to be enough in order to install all the Python packages and all the dependencies we need for this project. So I'm just going to edit this number, and I'm going to put something like 20 GB are going to be just fine. Then I'm going to click here on Launch Instance, and we need to wait a few seconds. Okay, so the instance has been created. I'm going to click here, and now I'm going to SSH into my instance so we can continue with this process. I'm going to click over here. This is going to give me all of this data, all of this information regarding my instance. I'm going to copy this value over here, and I'm going to open a terminal, and I'm going to type something like this, which is SSH-i, then my key pair. I need to select my key pair, and then Ubuntu at, and this value we have just copied, and I'm going to press enter. Okay, now I'm logged into my instance, and now it's time to continue with this process by executing all the instructions we have over here. So the first thing we need to do is to execute this command. So I'm just going to copy and paste this command over here. Then let's continue. We need to execute this other command. Okay, now this is very important. We need to execute this additional command, and this is where we are going to set up all the information we need to set up for this instance, right? We need to go back here, and we need to copy the public IP address of this instance. and then we need to get back here and paste the value over here, right? And that's pretty much all. So I'm just going to close this file. I'm going to save the changes and let's continue. And then we need to execute sudo service nginx restart. And that's going to be pretty much all. And then we need to update the EC2 security groups settings for your instance to allow HTTP traffic to the port 80. So I'm going back here, I'm going to security, then I'm going to select the security group, then edit inbound rules, add rule, custom TCP, port range 80, and then this will be anywhere IPv4. And that's pretty much all, save rules. And that's pretty much all we need to do. Now, we are going to copy and paste all the code we have over here. So I'm just going to copy everything we have produced in our local environment, and I'm going to create another file which is called main.py, and I'm going to paste everything over here. And that's going to be pretty much all. Okay. Obviously, we need to install the same dependencies, the same Python packages we have installed in PyCharm. And remember, these packages were Ultralytics, FastAPI, and also Ubicorn. And that's pretty much all. So I am executing pip install Ultralytics, FastAPI, Ubicorn, and I press enter. Okay, that's pretty much all. I'm going to clear this output. And now let's see what happens if we just execute exactly the same command we executed in my local computer. And I think in this instance, I need to execute Python 3. But other than that, everything should be just fine and exactly the same. Okay, I got this error. And if I'm not mistaken, this is something we can fix by running this command. We need to run an apt-get update, and then we need to install some additional packages. Let's see what happens. Okay, let's see now. I'm going to clear, and I'm going to execute this command again. And let's see what happens. Let's wait a few seconds. We forgot to download the ship classifier. I need to copy the ship classifier, obviously, because otherwise this is not going to work. So let's say one step at a time. Now let's copy the ship classifier. Let's copy the model into this instance. You can see that this is an SCP, so we are copying a file in my local computer, which is located here, right? And you can see that this is the ship classifier.pt model we were using a few minutes ago, and we are going to copy this file into this instance, into this directory, into the home directory. So I'm just going to press enter. And please be aware that if you are a Windows user, this command scp may work slightly different in your computer, so you may need to take a look on how to run this command or how to move this model into this instance, right? This may work slightly different if you are a Windows user, but in our case this is already copied into our instance, so I'm just going to get back here and I'm going to execute the same command again, and let's see what happens. And now everything seems to be working fine. We are deploying this web application in our instance, and now we should be able to access this API from our browser. So I'm just going to get back here where we have all the summary for all the information regarding this instance, and I'm going to copy the public IP. And then I'm going back here and I'm going to access this endpoint the same way we did in our local computer, in our local environment. And you can see that we are accessing this API and everything seems just fine. Everything seems just the same way it looked like in our local environment. So I'm just going to try it out. I'm going to copy and paste exactly the same image as before. And I'm just going to paste it here. I'm going to click execute and let's see what happens. Okay, we are predicting ship the same way as we did before, so everything seems just fine. I'm going to try with this other image and let's see what happens with this image of a dog. And we are classifying this image as no ship, so everything seems just fine. And we are ready. Everything is ready. Everything is completed. We have deployed this API into our server, into our EC2 instance, so we are ready to continue. The only thing I'm going to do now, let me show you. This is a very quick edit. I'm going to stop this process for now. We are going to resume it in a few seconds. I'm going to do something like this. I'm going to open a new screen. So I launch the process here. I'm just going to copy and paste the same command. And that's going to be pretty much all in order to launch this API from this other screen. But let's get back here. So everything is being deployed, but now let me show you something. If I do ls, you can see that, let me do a clear and now ls, you can see that this is the main.py file we have created. This is the ship classifier.pt file we are using as an image classifier, but we have also downloaded the two images we have just used, right? This is the doc.jpg image we have just predicted, and this is the JPG image we used over here, right? For every single image URL, we are downloading the image into our local computer, and that may not be exactly what we want to do, right? Because we want to make inferences, but we don't really want to save the data into our local computer. So I'm going to do something, which is I'm going to access this file, I'm going to edit this file, and once we have make our prediction, I'm going to call os.remove, and I'm going to remove the image. And the image will be located in the current directory, and it will be something like image URL.split, this character, and then the last element, right? Let me show you exactly why we are putting these values as input. And then I also need to import OS, and that should be pretty much all. So I'm just going to exit, and then I'm going to the screen we have in which we have launched our API. I'm going to launch it again. And basically what we are doing is we are taking a look at the entire URL file, the entire URL, and then we are just splitting this URL. We are splitting this string into many different values according to this character, and then we are just taking the last element from here, right? And the last element will be the image file name, and that's why we are removing this value, right? So everything seems to be just fine. Everything should be just fine now. And something else I'm going to do is I'm going to do another ls, and I'm just going to remove doc.jpg, and I'm going to remove ship.jpg, and that's pretty much all. So let's see what happens now. I'm going to call this API again. I'm going to execute exactly the same, and let's see if we are still getting exactly the same output. But let's see if now we are not saving the image, so everything is just fine. Okay, that was like a very quick edit, a very meaningless detail we need to edit in order to continue. But other than that, everything is just fine, and we have deployed our API in a server. Now we are ready to continue, and I'm going to show you how to publish this API in Rapid API. So let's get back to my browser. You need to go to rapidapi.com/have, and you are going to see something like this. Once you are logged into your account, you will be able to click here on My APIs, and this is where you are going to create a new API. So we need to select Add API Project. The name of this project will be whatever way you wanna call this project, but in my case I have already prepared a few sentences. I have already prepared some texts over here, so I'm just going to copy the name of this API, which will be Ship Image Classification. The description will be accurate ship classification from satellite images, enabling better maritime monitoring and navigation, right? This will be the description of this API. Now let's continue. Category, I'm going to scroll all the way down, and I'm going to select visual recognition. Then import data from, do not import, add API project. Once we have created our API, I'm going to upload a logo. I have already prepared a logo. This is the image we are going to use as logo. Then we are going to, what else? You need to add the terms of use. It's not mandatory. You can see that it's optional, but it's a very important thing to do. It's a very nice thing to have, right? Terms of use. So you let know to your users exactly what are the terms of use of your API. In our case, in order to make it a more simple process, I'm not going to add anything here. I'm just going to continue. But please remember, this is a very important thing to do in your API. Then visibility, I'm going to leave it as private for now, and later on we are going to make it public. Base URL, this is very important. This is the base URL of our API, and in our case, this is something like this value over here, right? The public IP of our EC2 instance. So I'm just going to paste this value over here. If I'm not mistaken, I need to do it with the HTTP. So I'm going to do something like this, and this is an HTTP. Okay. So save, let's see what happens. The data was successfully updated, so everything seems to be just fine. And then we are going to add a new endpoint, right? We are going here to definitions, and we are going to create REST endpoint. Then the name of your endpoint, in my case, is going to be ship classification, and the description will be submit satellite images to accurately identify and categorize ships for improved maritime monitoring and navigation, right? This will be the description of this API endpoint. Then we need to select post over here because this is a post method, and this is available in this endpoint over here, classify. Then we need to add an example, right? We need to add an example so the users know how to execute this endpoint, how to make requests to this endpoint. And this is where it's super important, this change we did over here regarding the way we are going to input the image URL, right? This is why we made this edit, this is why we have defined this class, and this is why we are putting the data the way we are doing it, like over here, right? This is exactly why we made this edit. Otherwise, we will not be able to edit this field over here. So I'm just going to name this as image URL, and let's just set an example which will be this image URL, right? And that's pretty much all. Okay. And that's pretty much all. So you can see that this is an example of how we could call this API. This is going to be published. Once we publish this API, this is going to be an example so the users know exactly how to make requests. You can see that we have examples in many different languages. This is in Node.js. We also have Ruby, we have R, Python, PowerShell, PHP, and so on. If I show you how the Python example looks like, you can see that this is the Python example. We are going to test this example. We are going to use this example in order to make sure our API is working properly, and this is pretty much all. So once everything is ready, the only thing I'm going to do is to click here on save, and we have created our endpoint. So everything is pretty much ready. We only have a few more steps left. So what I'm going to do now is I'm going to this tab over here, which is monetize, because obviously we want to make some money with this API. So you can see that here we have all of these different tiers, and we can just edit these tiers, and we can just put whatever price we want, and we can just put whatever conditions we want to these tiers. So I'm going to start here with the basic tier. This is going to be free, but this will not have unlimited requests, right? I'm going to constrain the number of requests of this basic tier to only 100, right? The user will be able to do 100 requests per month with the basic tier, with the free tier, and any additional request will be charged at this value over here, right? You can just put whatever value you want. I'm just making up some numbers in order to give you an example, but you can just put whatever other values and numbers you want. Okay, so this is pretty much all for the basic tier. I'm going to create a couple of additional tiers too. This is the pro tier, and this will be something like $50, and this is going to be pretty much all here. And then this is not going to be unlimited, but we will have something like, I don't know, 5,000 requests per month. This is a lot of requests, and this is going to be a hard limit, so the user will not be able to do any additional requests once the user has reached the 5,000 requests per month. And that's pretty much all. I'm just making up some numbers and I'm making up some conditions, so you can just do whatever you want with your API. And then I'm going to add an additional tier which will be priced. Let's see what's the maximum number. I'm just going to put 9s, save changes. Value should be maximum, this value over here. So this is going to be the value of my API, of this tier, which is the ultra tier. And it's around $1 million per month, right? I wish the users select this tier, because this is going to be amazing, right? Every single one of these subscriptions will be $1 million per month. Amazing. And this is not going to be unlimited either. This is going to be something like, I don't know, 100,000 requests per month, something like that. And it's going to be a hard limit, so the user will not be able to do any additional request. It doesn't make any sense. You may realize the conditions and the prices I'm setting up, they don't make any sense whatsoever. So you can just put whatever prices and whatever conditions you want for your API. But other than that, you can see that this is pretty much ready, and the only thing I'm going to do now is going back to general, and I'm going to scroll down, and now I'm going to set this API as public, so anyone can find this API. This is going to be amazing. So I need to select this box over here, and then I need to select this other box, and that's pretty much all. Now my API is public. I'm going to click save. And now let's see if we can find this API in Rapid API Hub search engine. So I'm going to search something like ship classification. And you can see that this is the API I have just created, ship image classification, and this is pretty much all. So we are going to have all the different examples, we are going to have all the description, everything, and this API is now created and it's now public in Rapid API. So the only thing I'm going to do now is to make sure everything runs smoothly. So I'm going to make sure I am able to execute this API with this example we have over here. I need to subscribe to this API first, so I am already subscribed, so everything's okay. And now I'm going back to PyCharm, because I am going to create a new file which is test.py, and I'm just going to copy and paste the code we have in this example over here, the Python code, the Python example, and let's see what happens. And you can see that we are getting this return, so everything seems to be working just fine. And this is going to be all for this tutorial. This is exactly how you can build and sell your own computer vision API, and this is going to be all for today. My name is Felipe, I'm a computer vision engineer, and these are exactly the type of videos and the type of projects I make in this channel. If you enjoyed this video, I invite you to click the like button, and I also invite you to subscribe to my channel. This is going to be all for today, and see you on my next video. So this is exactly the web application in which we are going to be working today on today's tutorial. This is a Pneumonia classifier, and let me show you exactly how it works. So I'm just going to drag and drop an image from my computer, and now let's see what happens. And you can see that we are classifying Pneumonia with a 99.9% confidence. So this is exactly the project in which we are going to be working today on today's tutorial, and I'm going to show you every single step of this process, from how to set up this web application up and running using Python and Streamlit, how to use the image classifier, and how to analyze its confusion matrix in order to validate its performance, and most importantly, I'm going to share some super amazingly pro tips in order to improve the performance of your model if something is not working as expected. If you're expecting everything to be super smooth and super straightforward, then think again, because when you are training an image classifier in real life or any type of machine learning model, things happen, and whatever whatever thing happens, whatever problem it arises with your model, with your classifier, you need to provide a solution, you need to fix the problem. And in order to fix the problem, you need to be creative, you need to think outside the box, exactly as we are doing over here. So this is what I want you to take from this video. This is by far the most important part of this tutorial. My name is Felipe, welcome to my channel, welcome to this video, and now let's get started. With this tutorial. This is exactly the data we are going to be using today. We are going to work with that Pneumonia dataset, and we will be classifying chest X-ray images into one of these two categories. We are going to be classifying absolutely every single image either as Pneumonia or normal. These are the two categories of today's tutorial, and now let me show you a few examples of each one of these categories so you see exactly how they look like. These are a few examples of the normal category, and you can see that we are looking at some chest X-ray images, and these are a few examples of the normal category. Now let me show you a few examples of the Pneumonia category. You can see that in this case we are also looking at some chest X-ray images. And I don't know about you, but in my case, I have to be honest, and these two categories, they look pretty much the same, right? I am not a doctor and I have absolutely no medical background whatsoever, so these two categories and all of these images, they look pretty much the same for me. And that's exactly why we are going to be using an image classifier in order to classify all of our images into one of these two categories. That's exactly why we're going to be using an image classifier to tell these two categories apart. So this is exactly the data we are going to be using in today's tutorial, and I'm not going to show you the process of building this image classifier because this is something I have already built before starting with this tutorial. I built the image classifier using Teachable Machine, using this website. And if you're curious to know the process of building an image classifier using Teachable Machine, then I invite you to take a look at all of my previous videos where I show you the entire process of building this image classifier. So if you're curious to know how exactly I built the image classifier we're going to use today, please take a look at that video I'm going to be posting somewhere over there. Now let's continue. This is the classifier we're going to use today. This is the classifier I have already trained. Pneumonia classifier.h5, it's already trained, it's ready, and we're just going to use it today. And now let's continue. Let's go to PyCharm because let me show you the PyCharm project we are going to work on today's tutorial. So you can see that I have three files over here. One of them is requirements.txt, the other one is main.py, and the other one is util.py. So these are the three files we are going to use today. Requirements.txt is the list of requirements you need for this project, and you can see we have NumPy, Streamlit, Pillow, Keras, and TensorFlow. So please remember to install these requirements before starting with this tutorial, otherwise nothing is going to work. And then if we move to main.py, you can see that this is the entire process we are going to be coding on today's tutorial. And this is exactly everything we're going to be doing today. This is exactly what it takes to make this image classifier available through a web application using Streamlit. So the first step will be setting up the title, then the header, then we're going to create a widget in order to upload a file, then we're going to load the classifier, and so on, right? The entire process is described as a sequence of steps, right? It's 1, 2, 3, 4, 5, 6, 7, 8 steps. That's all it takes to complete this tutorial, right? That's how simple this will be. So this is main.py, and now let's move to util.py. You can see that here we have two functions. One of them is set background and the other one is classify. For set background, this is a function we are going to use in order to change the background of the website we are going to be building today. So this function is only a detail, like a very meaningless detail, in order to make everything look much nicer and much prettier, but it's not really that important because it's not going to affect the entire functionality we are going to be defining here in this process. So that's why I thought it was a much better idea to just use this function from an utils file, so we don't really lose time coding this function, and we can just use it at the end of this tutorial, at the end of this process. Now let me show you this other function, which is classify, and this is a very important function. And you can see we have a very comprehensive description here in this docstring. You can see we have this function, exactly what it does, and we have all the description for all its parameters. But then if I scroll down, you can see this function is completely and absolutely empty, right? The only thing we have is this comments over here, these inline comments, and this is also like a sequence of steps the same way we had over here. So the idea is that we are going to be coding this function together on this tutorial, but we are going to do it at the end of everything else. We're going to focus on the entire pipeline, and once everything is ready and once we are happy with this pipeline, then we're going to get back here to the util.py file, and then we are going to code this function and we're going to make the real classification, the actual classification, right? But that's the process we are going to follow in this tutorial. We're going to start here with this process, and then we are going to classify an image. We're going to build the code for this classification, and then at the end we're just going to change the background, because that's going to be like the least important of all the details we're going to be doing today. So that's exactly what we are going to cover on this tutorial, and now let's get started with the main.py file. Okay, and the first thing we need to do is to import Streamlit as st. That's very important, because this is a Python package we are going to use in order to make this process available through a web application using Streamlit. So Streamlit is definitely important. And then the first step is to set up the title, and this is exactly how we're going to do. We're going to call st.title, and we're just going to set whatever title we want. I'm just going to write something like pneumonia classification, right? Pneumonia classification, everything's okay, yeah. So this is going to be the title of our web application, and now let's set the header, and this is something we're going to do, calling st.header, and the header is going to be something like please upload a picture, please upload an image of a chest x-ray, something like that. Or maybe we can rephrase it and something like please upload a chest x-ray image, right? This is going to be the header of our web application. So we're just instructing the user to upload a chest x-ray image in order to continue and in order to classify this image, right? Now let's continue. Now we are going to create the widget we need in order to upload a file, and this is something we're going to do, calling st file uploader. We're going to input two parameters. One of them is going to be an empty string, completely empty. And then we are going to specify what are the types we are going to accept in this widget, which I'm just going to do something like JPEG, JPG, and PNG, right? Which are some very popular formats for images, so I think we're going to be just fine with these three formats. Then we need to load the classifier we're going to use in order to make our predictions. And remember, I already showed you the classifier we're going to use today, which is this one. I already showed you the model, the weights of the classifier we're going to be using today, which is pneumonia classifier.h5, and this is where it's located within this model directory. So that's exactly what we are going to load now. But first we need to make an import. We're going to say from keras.models import load model, and now I'm just going to call load model, and I'm going to specify the location of my model, which is model, and then pneumonia classifier.h5, and this is my model. And that's it. That's how simple it is. And now let's load the class names. And in order to do so, we are going to use this file we have over here within the models directory, which is called labels.txt. And if you're curious to know where this file comes from, please remember to watch my previous video on how to train an image classifier using Teachable Machine, because in that video I explained the entire process, I explained the output, I explained absolutely everything. So by watching that video, you're going to understand where this labels.txt file comes from. Now, going back to PyCharm, this is exactly how we're going to load this file. We're going to do something like with open, and this is going to be module labels.txt. We're going to open this as R, as F, and then we're going to say something like class names is equal to, then we're going to do something like we're going to for A in F read lines, and obviously we are not going to mind the last character because that's a new line character, and that's basically all. But if I show you this file again, you can see that this is exactly how how this file looks like. We have a 0 and pneumonia, and we have a 1 and normal, right? So now the only thing we care about are the class names. So now the only thing we care about are pneumonia and normal. So the way I'm going to do it, I'm going to do it in a very, very generic way. So I'm going to do like this. This value that split the space, right? Remember, we have a space between the number and the word and the class name, and then I'm just going to keep the first value, right? So this is exactly how we are going to get all the class names from this file. It doesn't matter how many they are. This is exactly how we're going to get all the class names, and that's going to be pretty much all. In order to make sure everything works properly, I'm just going to print class names, and let's see what happens. Going to execute this file, and you can see that these are the two categories we are printing, pneumonia and normal, so everything seems to be just fine. And now something we could do to start working on this web application to see how it looks like, we can just run this file, and we should be looking at these two fields, right? The title, the header, and also the file uploader. So let's see how everything looks like so far. I'm going to my terminal, I'm going to clear this, and I'm just going to call Streamlit, and then I'm going to call run main.py. This is exactly how we are going to execute the code we have here, and exactly how we're going to launch this web application. This is exactly the text we have so far, which is pneumonia. Please upload a chest x-ray image, and then this widget we have defined over here as the file uploader. So far so good. So far everything looks just fine, and now let's continue. And now you can see that the next step in this process is to display the image the user has selected, right? So this is how we're going to do it. You can see that we are calling this value, and we need to say this is equal to file, and then we're going to say if file is not known, we are going to do something like this. We're going to define image as image.open file, right? An image we are going to import from pil import image. This is a function we're going to use in order to read the image the user has selected. And this is very important. We need to convert this image into RGB. Now let's continue. Now the next step is to visualize this image, is to display this image to the user, and we're going to call st.image. We're going to input this image, and then we are going to call this parameter, which is use column width equal to true. Right? This is exactly what we need to do in order to visualize this image, in order to display this image. And in order to move one step at a time, let's see how everything looks like so far. And if we go back to the browser, you can see that if I refresh, we are going to see exactly the same pneumonia classification. Please upload a chest x-ray image. And instead of selecting a file over there, I'm just going to select and drag one of the images in my computer. So this is exactly what I'm going to do, and this is going to take a few seconds. Now it's reading the image, it's processing everything, and now we are displaying this image in the browser, and the user is now super happy because it's visualizing the image it has just chosen from its file system. So everything is okay so far. Now let's go back to PyCharm, because now we need to follow additional steps. Now is the time we are going to make our classification. We are not going to make the real classification, but we are just going to call this very empty function in order to get these dummy values and in order to just move on, right? So what I'm going to do is from util import classify, and I'm just going to call this function. I'm going to call classify. I'm going to input the image, I'm going to input the model, and then I'm going to input the class names. And this is going to be equal to, if I go back here, this is going to return a tuple of the predicted class name and the confidence score for that prediction. So this is going to be equal to, I had an S missing over here, this is going to be class name, and then conf score equal to classify image model class names. Exactly what we need to specify according to this documentation we have over here. And remember, we are doing nothing. Everything is fully and absolutely empty. We are just going to get these 2 zeros. But it doesn't matter. Let's just take these 2 zeros and let's move on. Now, I'm going back here to main.py, and now let's just write the classification back to the user. So let's continue, and something that's very important, we need to make this within this if, otherwise we are going to have issues. And now we are going to call stwrite, and we are going to do something like, we are going to control the size of the text we are going to print by adding some these values, right? These characters. By adding these characters, we are going to control the size of the text we are going to write here. This is a very similar syntax as in GitHub, if I'm not mistaken, as in the README file of a GitHub repository. So this is where we are going to say something like, we're just going to print the class name. So this is going to be format class name. This is where we're going to write the category we are classifying, and then we're also going to write the confidence value, right? So we are going to make this a little smaller, so we are going to add an additional character, and then we are just going to say something like score, and this is going to be the conf score, right? So this is exactly what we need to do in order to write the classification. And so far we are returning a 0, 0, but actually if this is a class name, maybe it makes more sense to return something which looks like a class name. We're just going to return dummy class name and a 0, right? So we are detecting the class name called dummy class name and with a confidence value of 0, right? It doesn't make any sense whatsoever. This is only for debugging and in order to make sure everything is working properly. So now let's go back to the browser and let's see what happens. So I'm going to refresh. I'm going to load the same image again, and now we should be we should be displaying the image, and we should also be visualizing this new output, which is dummy class name score 0. So everything works properly so far. And if you notice, we have completed the web application. The web application is completed. I mean, the entire structure of the web application is just completed, and the only thing we need to do now is to code the classify function we have over here. But this process is done, it's completed. We have completed the web application. This is exactly why I divided the process into these 2 files, because this way is going to be much simpler to just focus on everything in the main.py file and then just make the classify function, right? We are just organizing the code. This is a very, very good practice, and I don't know about you, but I'm super happy because this is done, this is completed, and you notice how simple this is, right? So now let's continue. Now we're going to code this function, which is the classify function, and you can see that we also have a sequence of 1, 2, 3, 4, 5 steps. The first one is to convert the image we are getting over here to this size, 224 times 224. So this is exactly how we are going to do it. We need to make an import, which is from pil import image ops because this is the function we're going to use in order to convert the image we're getting into this size. So we're going to call image ops, and we are going to we're going to call image ops.fit, and we are going to input the image we are getting, and we are also going to input the size, which is 224 times 224, and then we are going to input a constant, which is image.resampling.lan SIDA OS, right? This is only a constant, a parameter we need to input into this function, but long story short, remember, we are just converting the size, we're resizing the image we are getting into this size, 224 times 224, and obviously we need to make another import, which is image, otherwise it is not going to work. And that's pretty much all. This is how we are converting the image, and the output is also called image. We're just going to overwrite the image we are getting. And now let's continue. Now the next step is to convert image as to a numpy array. So I'm just going to define a new variable, which is image array, and this is going to be numpy.asArray image, right? So we are getting the image, which currently is a pillow object, right? It's an image but in the pillow format, and we're just converting this image into a numpy array, right? And we are using the numpy library, which obviously I need to import numpy as np. Okay, and this is pretty much all in order to complete the second step in this process, which is convert the image to a numpy array. And now we need to normalize this image. So what we need to do, I'm going to define a new variable, which is normalize image array, and this is equal to, we are going to take the image array, we are going to cast it as type np.float32. we are going to cast it first into this value. We are going to take the image and we're going to convert it as float32, and then we're going to divide it by 127.5, right? Remember, so far the image goes from, every single pixel goes from 0 to 255. So if we divide it, we are making absolutely every single pixel goes from 0 to 2, right? So far every single pixel goes from 0 to 2. But if we do this, if we subtract 1, now every single pixel goes from -1 to 1, right? We have normalized our image array. And now let's continue. Now we are going to set the model input, and in order to do so, we are going to define a new variable which is called data, and this is going to be np_array, and this is going to be a shape equal to 1, because we are going to input one image at a time. Then the size will be 224, and then we will have 3 channels for every single image, right? So this is exactly the size we need. An image, only one image, 224 times 224, and 3 channels. And the type, this is very important, is numpy float32. Okay, the same type, we have converted our image over here. And that's pretty much all. And now the only thing we need to do is to define that the first element and the only element of data is the normalized image array we have over here. And that's pretty much all we need to do in order to set the model input, the data we are going to input the model. And now we have only one step left, which is making our prediction. Let's see how we can do that. We take the model as input. This is one of our parameters, the model. So the only thing we're going to do is call in model, and we're just going to input, we're going to call model.predict, and we're going to input the data we have defined over here. And this is our prediction, right? But now we need to unwrap all the information we need from this prediction, right? We need to get the class number we are predicting, and also the class name, and also the confidence value, and so on. Now let's define a new variable which is index, and this is going to be the index of the class we are detecting. And we are going to make it like this, and later on this tutorial I'm going to show you another way to get the index of the class we are detecting. I'm going to show you a very pro way to do it. I'm going to show you a much better way to do it as what we're going to do now, right? From now, let's just do it in a very classical way, which is argmax, and we are just going to input prediction, right? This way we are just going to get the argument of the maximum value of prediction. Prediction is going to be a vector with 2 values, and we're just going to get the argument, the index of the maximum number, and that's going to be the index of the class we are detecting. So from now on, class name is going to be class names, and we are going to input the index. Remember, class names is another parameter we take as input here. And then confidence score is just getting the prediction 0 because we only have one element, and then index, right? So this is exactly what we need to do in order to get the class name and in order to get the confidence score of the prediction we are getting over here. And that's pretty much all. And now the only thing we need to do is to replace this value and to replace this other value, and that's all, and that's it. So you can see how simple making this classify function is, and now you can see why I have divided the entire code into these 2 files, right? Because the first step is to complete the process in main.py, which was very simple, very straightforward, and then it's just to code these few lines in the classify function of the util.py file, right? And in only a few minutes we have an entire pipeline which is up and running, and we are just serving this image classifier into a web application using Streamlit, and that's it, right? So now let's test how everything works. Let's see what happens. And now let's go back to the browser. I am going to refresh, and I'm going to choose a couple of images of my dataset to see how it performs. So I'm going back to my file system, and I am going back until my test set, because obviously I'm going to choose a couple of images which are completely unseen data from my model, so we know exactly how the model performs. I'm just going to drag and drop an image in the pneumonia category, and let's see what happens. So we can see that we are detecting pneumonia. We are classifying pneumonia with a 99.9 confidence. So this is an amazing performance. This is amazing. So far the model is performing super well. Now let's see what happens with an image in the normal category. So let's go back here. I'm going to normal, and I'm just going to select an image from the normal category of my test set. I'm going to drag and drop the image here, and I'm going to wait a couple of seconds. And you can see that now we are also detecting pneumonia. We are classifying pneumonia too, and with a super amazingly high confidence. You can see that the confidence value of this classification, of this prediction, is 99.4%, which is amazingly high. So something is going on, obviously something is going on. And now let me show you something. I'm going to show you the confusion matrix of this classifier. This is the confusion matrix. I am sure you are familiar with the confusion matrix. Remember how it works. In the y-axis we have the true labels, and in the x-axis we have the predicted labels. And for example, this number over here, 384, means that 384 images in the pneumonia category were classified correctly as pneumonia, and only 6 images in the pneumonia category were classified incorrectly as normal. But if we look at the normal category, you can see that we have these numbers over here, and it means that only 70 images of the normal category were classified correctly as normal, and 164 images of the normal category were classified incorrectly as pneumonia. So something is going on with this classifier, and I have been inspecting many different images, and I have been inspecting this confusion matrix and so on, and I noticed that this image classifier is super biased to the pneumonia category. So long story short, it's most likely for a given image, it's most likely to predict pneumonia than normal. So pretty much it's classifying pretty much all images or most of the images as pneumonia, and it's not performing very well for the normal category, right? If we look at one category at the time, you can see that the accuracy in the pneumonia category is something like a 98%, right? Something like a 98%, but if we look at the normal category, it's only a 30 something percent or around a 30%. So that's what's going on, right? And I think this is very interesting because this is something that sometimes happens in real life when you are training a model. Sometimes it happens that you have a bias and the classifier is classifying one of the categories which are much more likelihood than the other category. And this is something that sometimes happens when you are building a model. This is something that sometimes happens in the industry, and sometimes it's not very clear why this is going on. Sometimes it's not clear why this is happening. Remember that we are predicting images which are chest x-rays, and as I mentioned when I was starting with this tutorial, when I look at these images, they all look pretty much the same because I have absolutely no medical background whatsoever. So it's very challenging for me to know what's going on with these images, to know what's going on with this data. Maybe if I Google